Hey guys, tonight we step into that quiet little pocket of the night where the moon feels like it's been waiting for you specifically, parked in the sky like a soft lamp someone forgot to turn off. You can picture it right where you are, even if you can't see it from your window, behind thin cloud, above rooftops, reflected in a puddle, smeared into silver across the edge of a curtain. The room is still warm from the day, but the light outside has cooled down into that pale, calm glow that makes everything look gentler than it has any right to. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you're up for it, drop your location and your local time down in the comments, because I love knowing where this night is reaching. Whether you're listening in the early hours when the world has gone quiet, or you're somewhere the evening is still fresh and the street noise hasn't fully given up yet. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're lying there with your mind doing its usual thing, flicking through thoughts like channels, until the moon quietly steals your attention. It doesn't need to flash or shout. It just hangs there with that slow confidence of something that has never once been late to its own schedule. And the wild part is that it feels close. It looks like you could reach up and touch it, like it's a coin pressed against the glass of the sky. But it isn't close at all. It's far enough away that if you drove toward it, no traffic, no fuel stops, just a ridiculous straight road through space, you'd be driving for days. The number is almost too clean to hold in your head. Roughly 384,000 kilometers on average. That's the kind of distance that makes your problems look smaller in a very polite way. Still, it keeps its promise to your eyes. It stays big enough to be comforting, bright enough to feel like company. And it's doing that trick with borrowed light because the moon doesn't produce its own glow. It's not a lantern. It's more like a beautifully timed mirror, catching sunlight and tossing it back across space with a softness that feels deliberate, even though it's just physics being its dependable self. Sunlight hits the moon, bounces off that dusty surface, and the result is what falls across your room. Thin, cool, and strangely emotional for something that's basically reflected daylight. Moonlight is faint too. Your brain calls it bright because everything else is dark, but compared to sunlight, it's almost nothing. It's like the difference between someone speaking to you in a whisper versus someone yelling through a megaphone. Under a full moon, the world is lit, sure, but it's lit in the way a hallway nightlight is lit. Enough to see outlines, enough to walk carefully, enough to make shadows stretch longer than they should. And those shadows feel different at night. They're less aggressive. They don't look like they're trying to prove anything. They just exist, quiet and calm, reaching across the floor like sleepy cats. If you've ever stared up and thought the moon looks extra huge when it's near the horizon, you're not alone. It's a classic human brain thing. Your eyes see it framed by buildings, trees, mountains, objects you understand as big, and your perception inflates the moon to match the moment. It's not actually swelling like a balloon. It's your mind using context to judge size, and your mind, bless it, is confident even when it's wrong. You can let that be comforting, though. Even your perception is trying to make the night feel more dramatic, more meaningful. It wants the moon to be magnificent, and it's willing to bend reality a little to get there. The moon's rhythm is another gentle hook. You know how it changes shape through the month, how it slides from a thin crescent to a bold half, then to a full bright face that makes the streets look washed in silver. That's not the moon changing itself. It's changing what it shows you. The moon is always half lit by the sun, always. The phases are just geometry and perspective, the angle between you, the moon, and the sun shifting day by day. It's like watching a slow turning, a gradual reveal, a quiet performance where nobody rushes and nobody needs applause. And because it's a reliable performance, your body notices it even when you're not trying. Some nights feel darker, more private. Some nights feel exposed, as if the moon is shining a spotlight into corners that were happier staying soft. The moon doesn't care about your schedule, but your brain cares about light, and even small changes can feel personal at 2:13 a.m. That's why a bright moon can make you feel awake in a way you can't quite explain, and why a thin crescent can make the night feel deeper, like the world has pulled a blanket up over its head. You can imagine the moon moving even if it looks still. It's always moving. It's gliding along its orbit around Earth with a steadiness that makes it seem motionless unless you give it time. If you watch long enough, you can catch it shift against the background, like it's quietly repositioning itself for the next part of the night. And while it orbits Earth, Earth turns beneath it, so the moon appears to rise and set, traveling across your sky like a slow, luminous thought. Nothing about it is hurried. It's just continuous. There's a calmer truth tucked inside that movement. The moon is basically falling around Earth. Not falling down, falling around. Gravity pulls it inward. Its sideways motion carries it forward. And the result is an orbit, a repeating curve that never quite hits and never quite escapes. It's a perfect example of the universe doing something that sounds like a contradiction until you relax into it. Falling but staying up. Moving but returning. It's the kind of paradox your mind can hold gently while you let your breathing slow. And you can feel its presence in the sky even when it's not visible. Sometimes it's up in daylight, pale and ghostly, as if it's trying not to bother anyone. Sometimes it's hidden behind clouds, and you only notice because the cloud edges glow brighter, outlined in silver like someone traced them with a pencil. That's another quiet fact that's easy to love. Moonlight doesn't just illuminate objects. It outlines them, gives them shape, makes the world look like a calm drawing. And maybe that's why so many people associate the moon with storytelling. It turns everything into a scene. When you look at the moon, you're also looking at something that doesn't change quickly. On Earth, everything is in motion: wind, water, plants, people, weather, time itself chewing at the edges of things. The moon, from this distance, is steady. It has no weather you can see, no drifting clouds of its own, no shimmering heat haze. It's a clean circle with quiet markings, like a face that keeps its expression. That steadiness hits a part of your brain that's tired of constant updates. The moon is the opposite of breaking news. It's the oldest notification, still there, still glowing, still doing its quiet job. Even the way it follows, you can feel intimate, and it's such a harmless illusion. You walk down a street, you change neighborhoods, you step into a different world of lights and sound, and the moon stays right there, as if it's keeping pace. It isn't chasing you, of course. It's just far enough away that your angle to it barely changes as you move. The moon doesn't need to keep up. It's already above the whole scene. And yet it feels like companionship, like the night has assigned you a gentle guardian that never speaks and never asks anything from you. If you've ever noticed that the moon looks a little warmer or a little colder, depending on the night, that's partly your atmosphere getting involved. The air between you and the moon is not empty. It's a thick, living layer of gas and dust and moisture that can tint and soften light. When the moon is higher in the sky, you're looking through less air, so it can look crisper, more cleanly white. When it's low, the light travels through more atmosphere, and the moon can take on a golden or orange tint, like a shy preview of the deeper colors it can wear during certain rare alignments you'll hear about later in this journey. Tonight, you're just letting yourself notice how the air can act like a lens and a filter, gently repainting the same moon in a slightly different moods. And your eyes adapt. That's another small, comforting piece of science. Your vision literally changes in low light. Rod cells in your retina become more active, your pupils widen, your brain turns up the gain, like it's adjusting an old radio. That's why the moon can feel brighter after you've been in the dark for a while. The night isn't getting lighter. You're getting better at receiving it. There's something sweet about that. Your body quietly meeting the night halfway, doing its own careful work while you rest. So you stay with the moon for a moment, letting it be a single, simple anchor. The thought that it's the same moon over oceans, over deserts, over cities that never truly sleep. The same moon that's been looked at by people who had no electric lights, no satellites, no idea what its surface was like, just that it was there, cycling through shapes, setting a tempo for the night. It's not an emotional thing, technically. It's just a rock reflecting sunlight. But the universe does this all the time. It makes something simple, then hands it to human minds, and human minds make it meaningful. You can let your attention narrow to the way moonlight lands on objects. The edge of a pillow, the corner of a wall, the curve of your hand if you lift it slightly. It's soft enough to be gentle, bright enough to be real. It doesn't demand anything. It just exists, and it makes the world look a little quieter than it did a few hours ago. And as you settle into that quiet, you begin to sense that the moon isn't only scenery. It's history floating above you. It's motion you can trust. It's a steady presence that will keep circling even if you fall asleep mid-thought, even if your playlist ends, even if your dreams take you somewhere far away. The night can feel large and mysterious, but the moon makes that mystery feel safe, like a locked door in a house you already know, not like a wilderness. You keep watching in your mind, letting the moon hold the center of your attention just a little longer, because there's comfort in focusing on something that has no urgency, no deadline, no push notification attached to it. Just a pale, patient light, and the sense that there's a lot more going on up there than the quiet glow suggests. You keep that moonlit stillness in your chest, and curiosity slips in like a warm draft under a door. The moon looks so settled, like it has always belonged to your sky, but it had to arrive somehow. And its best origin story is the kind the universe tells with a straight face, a catastrophe that eventually becomes a comfort. The early solar system is not the tidy clockwork you imagine from textbook diagrams. It's more like a crowded dance floor where everybody is bumping shoulders, except the dancers are half-formed planets and the music is gravity. Young Earth is hot, unfinished, still sorting itself out. Nearby, another world-sized body shares the neighborhood, moving along an orbit that is not exactly respectful. Scientists often nickname it Theia. It sounds elegant, which is hilarious because the role it plays is basically cosmic battering ram. In the leading explanation, called the giant impact hypothesis, Theia collides with Earth at an angle. Not a clean bullseye, not a gentle kiss. A glancing, high-energy hit that tears up rock and melts it, flinging a vast amount of debris into orbit. For a while, Earth was a swirling disk of vaporized stone and molten fragments, glowing with heat rather than light. If you could watch it safely, it would be gorgeous in the way a thunderstorm is gorgeous from behind a window, terrifying in the past tense, mesmerizing in the distance. Then comes the part that feels almost soothing to picture. The debris doesn't stay scattered. It begins to gather. Gravity does what gravity does. It collects. Pieces collide, merge, and grow into larger clumps. Clumps become one dominant body. The moon is born from a ring of rubble, assembled by a patient rule that never gets tired. Early on, that newborn moon is likely molten, at least on the outside, and possibly deep down too. Imagine a global ocean, but it's magma, slow-moving liquid rock, heat rising, heavier stuff sinking. It's not chaos anymore. It's sorting. The moon starts to separate itself into layers, like a storm settling into a calm, clear sky. As it cools, a light mineral called plagioclase feldspar becomes important. In a magma ocean, some minerals are buoyant enough to float upward. Over time, that floating material can form a pale crust. This is one reason the moon's oldest regions, the highlands, look brighter than the darker plains you can see with your own eyes. You're looking at the moon's earliest skin, formed when the surface first learned how to be solid. And because the moon has no rain to grind mountains down, no rivers to carry rock away, no wind to sandblast edges smooth, it keeps what it forms. Earth is a world that constantly edits itself. The moon is a world that archives. It holds onto ancient surfaces the way a quiet person holds onto memories. Not loudly, just faithfully. This impact story exists because the moon is stubbornly specific. It's big compared to its planet. Oddly big, honestly. In the solar system's lineup of moons, ours is not a tiny tag-along. It's a substantial partner in the sky, large enough to feel like a presence instead of a decoration. A giant impact can throw enough material into orbit to build something that size. The moon is also less dense than Earth, hinting at less iron overall. Earth has a large iron-rich core. The moon's core is much smaller by comparison. If most of the moon formed from the outer layers of early Earth, mantle material rather than core material, then it makes sense that the moon would end up more rock than metal, lighter in bulk, softer in its gravity. There's another clue that feels almost intimate. Moon rocks and Earth rocks have striking similarities in their chemical and isotopic makeup. When humans brought back lunar samples, those pieces didn't feel alien in the way you might expect. In many measurements, they looked like close relatives. That supports the idea that the moon is, in part, made from Earth's own material. Earth thrown outward, cooled, and returned to us as a companion. Of course, nothing cosmic is allowed to be perfectly simple. The similarities are so strong that they force the story to be refined. Maybe the impact mixed material more completely than early models imagined. Maybe the impactor formed in a similar region of the solar system and happened to share Earth's signature. Maybe the collision created a hot disk where vaporized rock blended thoroughly before the moon assembled. It's a gentle kind of mystery. Not we have no idea, but the details are still being polished, like a sculpture still receiving its final careful sanding. Even the moon's relationship with Earth continues to evolve, just quietly enough that you can miss it your entire life. After it forms, the moon is likely closer than it is tonight. Over immense spans of time, tidal forces trade energy between Earth and moon. Earth's rotation slows a little. The moon's orbit expands a little. The moon drifts away at a rate you can measure in centimeters per year, about the pace of fingernails growing. That's almost funny. A celestial body inching away with the patience of biology. Those same tidal forces also shape how the moon behaves in the sky. Over time, the moon becomes tidally locked. Its rotation matches its orbit, so it shows Earth almost the same face all the time. It's not doing you a favor, but the effect feels oddly personal anyway. You can lie there and look up at a familiar pattern of dark plains and bright highlands and know that billions of years of gravity have trained the moon into this steady, consistent presentation. And the hidden half, the far side, adds a soft edge of wonder. Half the moon stayed out of view for all of human history until spacecraft revealed it. That means the object you think you know is also an object with a private face. Familiar, but not fully. Close enough to feel like a friend, distant enough to keep secrets. So the calm light you started with has a deeper origin than it looks. The moon is the cooled outcome of a collision that would have vaporized landscapes and turned rock into mist. The comfort is that all of it is over. The chaos finished its work, the heat radiated away, the molten seas froze, and what remains is a steady disk in your sky, an ancient, quiet witness that came from Earth and still circles Earth, keeping time without making noise. You rest with that thought. The universe can be violent, yes, but it can also take the aftermath, wait a few billion years, and turn it into something gentle enough to paint silver onto your wall. That steady disk in your sky starts feeling less like a simple circle and more like a face you can actually read the longer you give it your attention. You've probably noticed the dark patches first, because your eyes love contrast. Those broad, smooth-looking areas, like spilled ink on pale paper, are what made people start seeing shapes up there. A rabbit, a man, a woman, a whole little mythology, depending on where you grew up and what stories were waiting for you. Your brain is basically a pattern-finding machine that refuses to clock out, even at bedtime, and the moon is one of its favorite puzzles. Here's the quietly funny part. Those dark regions were called seas by early astronomers, because through early telescopes they looked like calm oceans. The name stuck. It's very on-brand for humans to name something confidently and then never correct it, even after we learn it's not water. So the moon has Maria, Seas, with names that sound like poetry. Sea of Tranquility, Sea of Serenity, Sea of Crises, Ocean of Storms. It's a whole catalog of mood lighting, and not one drop of it is liquid. Those seas are rock. Basalt, specifically dark volcanic rock, the kind that forms from lava that cools and hardens. You're looking at ancient lava plains that spread out and filled low areas like ink sinking into paper fibers. It's comforting in a strange way because it means the moon had its own era of heat and flow, its own chapter where it wasn't just sitting there quietly. It moved, it changed, it had internal fire, and then it learned how to go still. The story underneath those dark patches starts with impacts because the early solar system wasn't subtle, as you've already gathered. Giant collisions carved enormous basins into the moon. Think of them as bowls punched into the crust, vast depressions ringed by fractured mountains. Afterward, when a moon was still warmer inside than it is today, magma could rise more easily through cracks. Over time, lava welled up and flooded those basins, smoothing them out, creating broad plains that reflect less sunlight than the brighter highland around them. Darker surface, lower reflectivity, more contrast. Your eyes notice them immediately, and your imagination gets to work. The bright parts, those are the highlands. They're older, much older. They're the moon's ancient crust, heavily cratered and rugged, made largely of lighter-colored rock. Remember that early magma ocean idea? The moon cooling down, minerals separating like a slow-settling snow globe? The highlands connect to that. A lot of that bright crust is rich in a mineral called plagioclase feldspar, which makes rocks like anorthosite. It's pale, it reflects more light, and it forms that classic bright moon look in the areas not drowned in basalt. So when you stare at the moon, you're seeing an age map in light and dark. The highlands are the old pages of the book, pocked and worn, filled with overlapping crater stories. The Maria are younger chapters, still ancient by human standards, but younger by lunar standards, smoother, darker, more like a page someone hasn't scribbled on as much. If you want a trick for feeling that difference without any telescope, let your eyes soften the details and just notice texture. The Maria looks smoother because lava filled in the roughness. The highlands look busy because they've been taking impacts for a longer time without being resurfaced. On Earth, impacts get erased. Wind, rain, tectonics, plants. Earth is an obsessive cleaner. The moon is the friend who keeps every message thread from 2009. Nothing really gets deleted. The only major editor is new impacts, and even those mostly just add more marks. Crater density is one of the simplest ways scientists tell old from less old on the moon. In general, the more craters piled up, the older the surface. The highlands are crater-rich, ancient, battered, crowded with scars. Many of the Maria have fewer craters, still hit, still marked, but comparatively smoother, as if the moon had the decency to lay down a fresh dark rug over the damage before it cooled down and stopped doing that kind of thing. And your eyes pick up the contrast because of albedo, how much light a surface reflects. The Maria are darker, lower albedo. The highlands are brighter, higher albedo. It's not because one is dirty and the other is clean. It's just rock chemistry and texture. Basalt tends to be darker. Feldspar-rich anorthosite tends to be lighter. The moon is basically showing you geology in grayscale. Those poetic sea names start feeling even more satisfying when you realize what they are attached to. The Sea of Tranquility is a basalt plain inside a giant basin. The Ocean of Storms, Oceanus Procellarum, sprawls across a huge region on the near side. Mare Imbrium, the Sea of Showers, sits in a massive impact basin with a ring of mountains around it. When you learn the names, the moon starts to feel like a map you've always known, but never bothered to read closely. And then you can't unsee it. You look up and you're not just seeing the moon. You're seeing landmarks. There's another quiet detail that makes the moon feel more mysterious the more you learn. Most of the Maria are on the side that faces Earth. The near side, The face, has the big, dark lava plains. The far side has far fewer of them, and it's more uniformly bright and heavily cratered. That imbalance is one of those facts that sounds like it should be a plot twist because it kind of is. If the moon is a sphere, why would one side get most of the lava flooding? Part of the answer comes down to crust thickness. The far side's crust is generally thicker, which makes it harder for magma to push through. The near side's crust is thinner in many places, especially under the big basins, so lava had an easier time reaching the surface. A thinner crust is like a door that opens with less effort. A thicker crust is like trying to push a couch through a doorway that is technically wide enough, but makes you question your life choices. Heat inside the moon matters too. The moon isn't hot inside the way Earth is, not anymore, but it did have more internal heat in its past. Where that heat was concentrated and how it escaped could influence where volcanic activity happened most. There are also regions on the moon rich in certain elements: potassium, rare earth elements, phosphorus, often discussed together because they show up in a particular way in lunar samples. Those elements can be linked to internal heat production through radioactive decay, a slow, steady release of warmth over time. If you're thinking, so the moon had a side that stayed warmer longer, you're thinking along the right lines. A slightly warmer interior means magma stays mobile longer. Longer mobility means more lava flows. More lava flows means more Maria. Even without chasing every detail, you can let the big idea settle. The moon's face isn't random. The pattern you see, those dark patches arranged like a familiar expression, comes from a combination of early violence and later calm. Big impacts created basins. Internal heat provided lava. Lava filled the basins. Then everything cooled and stayed mostly still for an incredibly long time. It's chaos followed by quiet, written into rock. And that's why the man in the moon looks the way it does. The features people stitch into a face are really ancient lava plains of different sizes and shapes, bordered by bright highlands that act like outlines. Your brain draws the rest. It's like looking at clouds and seeing a dragon, except the cloud is a world and the dragon is billions of years old. If you ever get the chance to look through binoculars or a small telescope, the moon becomes even more hypnotic because you can see the boundary zones where dark meets light. Those edges are not blurry. They're sharp in places because there's no air to soften them. The transition from mare to highlands can look like spilled ink that dried in a hurry. You can spot crater rims standing out like pale rings, and you can see how some craters have bright rays, streaks of lighter material thrown out during impact, spraying across darker plains like someone flicked paint. Those rays are another soothing detail because they remind you the moon is still being gently worked on, even now. Not dramatically, not nightly. But over long time scales, it still gets tapped by smaller objects. When an impact happens, it can expose fresher material underneath the weathered surface, making bright lines you can sometimes see with your eyes from Earth. Over time, those rays fade as the surface gets space-weathered, darkened and altered by micrometeorite impacts and the constant stream of particles from the sun. Even fading happens slowly up there, like the moon is allergic to hurry. The more you think about it, the more the moon becomes a calm museum of processes you can't normally watch. Lava that moved like liquid and then froze. Impacts that shattered rock and left rings and rays. Crust that formed from floating minerals on a global magma ocean that endured for ages without rain or wind to erase it. You're lying in your bed, and above you is a world that keeps the record of its own making in plain view, if you know how to look. And you don't have to do anything with that knowledge. You don't have to memorize names or measure crater diameters or pretend you're about to sit an exam on lunar geology. You can just let it make the moon feel deeper. The light on your wall isn't coming from a blank object. It's coming from ancient plains of hardened lava, surrounded by old bright crust, carved and written on by time in a way Earth refuses to allow. The moon is quiet, but it isn't empty. It's full of history that has settled into a face you can recognize from your childhood, even if you only understand the details tonight. That light on your wall has a secret, and it's almost charming how unromantic the secret is. The moon isn't glowing. It's not a lamp. It's not a pearl with its own inner fire. The moon is basically the friend who shows up to the party wearing someone else's jacket and still gets compliments because it carries the look so well. Moonlight is sunlight on detour. Every pale stripe across your curtain began at the sun, left in a burst of heat and pressure you can't really picture without your brain trying to turn it into a campfire. Those photons traveled for minutes across space, hit the moon, and then only a small fraction of them bounced back toward Earth, slipped into your atmosphere, got nudged around by air and dust, and finally landed in your room as something you're willing to call soft. The moon doesn't reflect much, honestly. It looks bright because it's sitting in a dark sky and it's big enough for your eyes to latch onto. But the lunar surface is more like dark asphalt than polished marble. A lot of sunlight hits it and gets swallowed into rock and dust. Only a modest portion comes back. That's why moonlight feels gentle even at its strongest. A full moon can brighten a landscape, sure, but it's still the quiet version of brightness, like the universe turned the dimmer down and then decided to keep it there out of pure manners. You can feel that dimmer effect in your body if you pay attention. Under sunlight, your visual system is spoiled. Colors pop, edges snap, everything is high definition. Under moonlight, your eyes switch modes. The cones, those color-sensitive cells, start handing the job over to rods, which are more sensitive in low light but not great at color. Rods are the reason you can walk through a room at night without bumping into a chair like a confused penguin. But they're also the reason your world turns into a soft grayscale when it gets dark enough. That's part of why moonlight seems silvery. It's not that the light itself is magically silver. It's that your night vision is a little colorblind, and your brain fills in the gaps with cool tones. There's also a trick called the Purkinje shift. Your eyes become more sensitive to shorter wavelengths in low light, so blues and blue-greens can feel more noticeable than reds. Under moonlight, warm colors fade first. A red flower becomes a darker smudge. A blue object hangs on longer. So your brain gets this overall impression of coolness, even though the physics is basically just sunlight reflected off dust and rock. And if you want to get even calmer about it, there's something sweet in realizing that what you call white is never truly white. Sunlight itself is a blend, a wide spread of wavelengths. When it bounces off the moon, it gets tinted subtly by whatever minerals and dust grains it strikes. Those dark lava plains you were picturing, the Maria, absorb and scatter light differently than the bright highlands. The highlands reflect more overall, so they look brighter. The Maria reflect less, so they look darker. Same sunlight, two different surfaces, one familiar face. Your atmosphere adds another gentle layer. Even on the clearest night, you're looking through a thick soup of air. Moonlight gets scattered slightly as it passes through, and that scattering can soften contrast and smear the edges of the light in a way that feels forgiving. If the night has haze, humidity, thin cloud, smoke from a faraway burn, that effect increases. Moonlight becomes a wash instead of a beam, and the whole sky can start to glow instead of staying sharply black. It's the night version of diffused lighting, the kind photographers try to recreate with expensive gear. The atmosphere does it for free with zero interest in your Instagram. You can test how faint moonlight really is by doing something simple. Hold your hand a little above your blanket and look for the shadow. Under a bright full moon, you might see a shadow, thin and shy, but there. Under a crescent moon, it's much harder. You start to realize that moonlight is strong enough to sketch outlines, not strong enough to paint details. It's a pencil, not a brush. That's part of why shadows feel kinder in moonlight. In strong daylight, shadows have authority. They're crisp, high contrast, like someone used a sharp blade to cut darkness out of light. Under moonlight, the whole world is operating on lower contrast. Your pupils widen, your eyes gather what they can, and your brain smooths the scene so it stays usable. The darkness isn't carved, it's blended. Edges soften. The shadow's border becomes a gradient. Even a faint shadow across pavement looks less like a warning and more like a lullaby pattern. The moon's shape helps too. A point light source creates a harder shadow. A larger, extended light source creates a softer edge because light arrives from slightly different angles, producing a penumbra, an in-between zone where the shadow fades out rather than snapping off. The moon isn't huge in the sky, but it's wide enough to make shadows slightly less severe than a true point of light would. Add the atmosphere's scattering, add reflections from nearby surfaces, and shadows become less dramatic, more like quiet stains on the ground. Then there's the emotional part your brain sneaks in without asking permission. Daylight tells you it's time to do things. Moonlight tells you it's time to stop doing things. It's the same sun, technically, but moonlight arrives after it's been humbled, after being dimmed by distance and reflection, filtered by rock dust, and softened by air. It's sunlight that has learned how to speak quietly. There's a little cosmic comedy in the moon's timing, too. It's always performing the same trick, brightening and fading across the month like it's breathing. When it's full, moonlight can feel almost theatrical, bright enough to make streets shimmer, bright enough to give trees a thin silver edge. When it's a crescent, the light is minimal, just enough to make the moon's curve look like a clipped fingernail in the sky. The rest of the disk can vanish in a black, and that blackness can look absolute, unless you catch a certain ghostly glow. That ghostly glow is one of the moon's gentlest flexes. Sometimes, when the moon is a thin crescent, you can still faintly see the rest of its face, dim, gray, almost like a secret. That is Earthshine. Sunlight reflects off Earth, cloud tops, oceans, ice, deserts, bounces toward the moon, and softly illuminates the moon's night side. You're seeing our planet's light painted on a lunar rock. It's the Earth acting like a mirror for the moon, returning the favor, like a quiet exchange between two bodies that have been together for an absurdly long time. Earthshine is especially soothing because it makes the moon feel less lonely. It's not just the sun and a rock. It's a little triangle of light, sun to earth to moon, and back to you. The night becomes a system, a relationship. You can lie there and imagine the Earth's bright day being reflected outward while you rest in the dark, like the planet is keeping a night light on for you. And because moonlight is so faint, your perception becomes part of the experience in a bigger way. Your eyes adapt gradually. The longer you stay in low light, the more sensitive your vision becomes. It's like your body slowly turning up the volume on sight. That's why stepping outside after sitting in a dim room can make the moon suddenly feel brighter. It didn't change. You did. You became better at receiving it. That receiving has a cost, and it's a strangely comforting one. Your world becomes less detailed. Your brain stops trying to resolve every edge. It stops obsessing over tiny imperfections. It leans into broad shapes and gentle movement. Under moonlight, you don't see your life in high definition. You see it in an older format that's easier on the nerves. If the moon is low on the horizon, the light can turn warmer, and the whole thing can feel like a quiet hearth in the sky. If it's high and the air is clear, the light can feel whiter and colder, almost clinical, but still soft because it's weak. That's a nice contradiction. Moonlight can look crisp without being harsh. It can look sharp without being loud. It has clarity without pressure. Even the way it lands on textures is different. In daylight, textures shout. In moonlight, textures whisper. A rough wall becomes a smooth gradient. Wrinkles in fabric become gentle waves instead of little problems you should iron. The moon makes everything look more forgiving, like it's politely refusing to judge your choices. And that might be the most relaxing science fact of all. Low light reduces visual noise, and your brain interprets that as peace. So you keep the moon in your mind, not as an object, but as a kind of filter laid over reality. Sunlight, humbled and softened. Rock, dust, and air cooperating without trying. A light that isn't powerful enough to demand anything from you, only steady enough to keep you company. That softened sunlight has been doing more than decorating your curtains. It's been distracting you from the moon's real hobby, which isn't glowing romantically in the sky like it's posing for a calendar. Its real hobby is gravity. Quiet, constant, and a little bit intrusive, like a neighbor who never knocks but somehow still feels polite about it. You already know the headline version. The moon causes tides. But the calm, slightly mind-bending truth is that it doesn't just pull the ocean toward it like the sea is a pet on a leash. It's subtler, smoother, and honestly more elegant than most things humans build. Gravity from the moon pulls on Earth. It pulls on the water, yes, because water moves easily, but also pulls on the land beneath the water. Earth isn't a rigid ball of stone. It flexes. It deforms slightly. The whole planet responds. The ocean is simply the part of the system that makes the motion visible, like a curtain that moves when the air shifts, revealing the draft you couldn't see. The key idea is the gravity difference across Earth. The moon's gravity is stronger on the side of Earth facing it, because that side is closer. It's weaker on the far side, because that side is farther away. That difference, stronger here, weaker there, creates a stretching effect, a gentle tug-of-war across the planet. The ocean responds to that stretch by forming bulges, one on the side facing the moon and another on the opposite side. That second bulge, the one on the far side, always surprises people the first time they hear it. It sounds like the ocean is being pulled away from the moon, which feels like an insult to basic logic. But it's not that the moon is pushing anything. It's that Earth itself is being pulled. The center of Earth is pulled toward the moon. The near side is pulled even more. The far side is pulled less. Relative to Earth's center, the far side is left behind a bit. The ocean there ends up bulging outward because it's not being tugged as strongly as the planet's middle is. It's all about differences, not absolute pulls. The moon doesn't yank the ocean like a rope. It stretches Earth's whole environment in a slow, balanced way. So you get two high tide bulges, roughly opposite each other. And because Earth rotates underneath them, most coastlines experience two high tides and two low tides each day. Not exactly every 12 hours on the dot, because the moon is moving in its orbit too. The timing slides. The moon rises a little later each day, and the tides follow that schedule like a faithful, slightly sleepy assistant. If you've ever been near the ocean and felt the tide schedule seems oddly late, or the high tide doesn't match the neat chart you saw online, welcome to the part where reality refuses to be a perfect diagram. Tides are affected by coastlines, seabed shape, bays, continental shelves, and how water sloshes around inside the basins of the world. The moon sets the rhythm, but the oceans add their own personality. Like drums in a band, steady beat, but different rooms sound different. Some places get gentle tides, small rises and falls that feel like the sea breathing quietly. Other places get dramatic tides, where the water retreats and returns with real theatrical commitment, revealing stretches of seabed like the ocean is pulling back a blanket and then tugging it up again. Narrow bays can amplify the effect because they funnel and resonate. Shallow shelves can make the movement more noticeable. Coastlines turn lunar gravity into local choreography, and the moon isn't acting alone. The sun joins in like a second musician who insists it's just here to support, while secretly being very powerful. The sun's gravity also affects tides, but because it's so far away, the tidal effect from the sun is weaker than you might guess from its eyes. It's still significant, though, and when the sun and moon line up in certain ways, they either cooperate or get in each other's way. When the moon is new or full, the sun, Earth, and moon line up. Their tidal forces combine, reinforcing each other. That produces spring tides, which has nothing to do with the season and everything to do with the sense of springing forth. Spring tides bring higher highs and lower lows. The ocean's breathing becomes deeper. When the moon is at first or third quarter, those half-moon phases, the sun and moon pull at right angles relative to Earth. Their tidal effects partly cancel each other out. That produces neap tides, with less dramatic highs and lows. The ocean's breathing becomes shallower, like it's resting between bigger exhalations. There's something strangely soothing in that. You're not just living through random waves and weather. You're living under a repeating pattern set by celestial geometry. Twice a month, deeper tides. Twice a month, gentler tides. A steady alternation that has been happening longer than human calendars, longer than written language, longer than most of the landscapes we take for granted. And because humans are humans, we built our own rhythms on top of it. Fishing traditions, harbor schedules, coastal routines. Entire cultures shaped by the tide table. People learned, without knowing the physics, that the sea has a mood. That mood has timing. That timing can be trusted most of the time, which is more than you can say for your group chat. You can take it even quieter. Tides aren't only about the ocean. There are earth tides, tiny rises and falls in the solid ground. The land beneath you flexes by small amounts as the moon's gravity changes through the day. You don't feel in your feet because it's subtle and spread out, like the slow bend of a giant trampoline. But it's happening. The planet is not a fixed stage. It's a responsive body, shifting in time with the moon's position. So if it helps you relax, imagine Earth as a living instrument. The moon plays it gently. The oceans respond with visible motion. The continents respond with barely noticeable flexing. The whole thing is a slow pulse. Steady, dependable, indifferent to your worries, and yet strangely comforting because it continues whether you're anxious or calm. The moon doesn't negotiate. It just does gravity. There's also a long-term consequence hidden inside this daily motion, and it's almost sweet how patient it is. Those bulges aren't perfectly aligned with the moon because Earth is rotating. The ocean's movement, friction with the seafloor, and the planet's own responsiveness cause the tidal bulges to be dragged slightly ahead of the line between Earth and Moon. That offset matters because gravity becomes a two-way conversation. The moon pulls the bulges, and the bulges pull back on the moon. That back and forth transfers energy. It slowly slows Earth's rotation. Tiny amounts, so small you won't notice tomorrow, but over immense time it adds up, and it gradually pushes the moon outward, increasing its orbital distance bit by bit. You can think of it as the moon getting a gentle allowance of angular momentum, paid out in millimeters and centimeters, over millions of years. Nobody is rushing. The universe doesn't do rush. There's a calming lesson in that too. The tides are not just scenery. They're an energy exchange, a slow trade between spin and orbit. A reminder that even steady things change, just at a pace that doesn't demand your attention. The day lengthens, the moon drifts outward, the rhythm stays. Your life continues on a scale where all of that feels like background music. And this is where your own sense of time gets quietly massaged. You might be lying there thinking your day was chaotic, full of small, sharp moments. Then you remember, the ocean has been lifting and lowering on schedule while you were answering emails. The tides were doing their slow work while you were stuck in traffic. Somewhere on the planet, at this exact moment, water is slipping back from a beach, exposing wet sand, leaving shells and seaweed and little patterns that look like handwriting. Somewhere else, water is rising, covering rocks, smoothing jagged edges with foam. All because the moon is there and gravity behaves like gravity. If you want to picture it, imagine the ocean as a giant sheet draped over Earth. The moon's pull stretches the sheet into two gentle humps. Earth turns. Coastlines pass through the humps like a slow, moving hand through a stream. Twice, the water reaches higher. Twice, it relaxes and falls away. The sea isn't randomly restless. It's following a quiet, celestial beat. And even if you live far from the coast, even if you never look at a tide chart, you're still on the same planet being gently tugged. The same moon is shaping the world's water and, by extension, shaping the atmosphere and weather patterns in subtle ways, shaping ecosystems that depend on tidal zones, shaping creatures whose lives are timed to those changes. It's all connected, and none of it needs you to manage it. That thought can feel like relief. Your mind doesn't have to hold everything up. The moon holds the tides in motion without effort. Earth turns without asking. The ocean keeps breathing. You can let that rhythm carry you for a while, like lying on a dock and feeling it rise and fall beneath you, trusting the water to do what it has always done. That ocean-breathing rhythm makes the moon feel like a gentle conductor, but it has another role that's less cozy at first glance and somehow ends up being even more comforting once you understand it. The moon has spent most of its life being a target, not in a dramatic, fireworks every night way. More like a quiet bulletin board where the universe has been pinning notes for billions of years. When you look at the moon's face, you're seeing the evidence of impacts layered on top of impacts, like overlapping fingerprints. On Earth, those fingerprints get wiped clean. Wind scrubs, rain dissolves, rivers erase, plates shift, plants move in like they own the place. Earth is a restless editor. The moon is an archivist. It doesn't rewrite the page. It keeps adding marks to it. The earliest solar system was messy in a way that makes modern life seem organized. There were more stray rocks, more leftovers from planet building, more objects crossing paths that shouldn't. The moon formed into that traffic. It didn't get to choose a quiet neighborhood. It simply became a stable thing in an unstable time, and stability attracts collisions the way a still pond attracts thrown stones. A crater is the moon's way of recording a moment when something arrived too fast to stop. There's no gentle landing. An impactor, anything from a grain of sand to a mountain-sized rock, hits at incredible speed, and the energy of that speed becomes heat and shock and excavation. You don't get a neat hole drilled into the ground. You get rock that behaves like fluid for a few seconds, because under that much pressure, solid stone forgets how to be solid. That's one of those facts that feels like it should be illegal. Rock flowing, not as lava, not as something melted, but as a temporary, violent response to a shock wave. The surface compresses, it rebalances, material blasts outward. A bowl-shaped crater forms for smaller impacts, and for larger ones, the center can spring back up into a peak, like the surface is trying to correct itself after being punched. Some big craters even have rings, multiple circular ridges, because the impact is so large it restructures the crust in stages. The moon's most dramatic basins are like ripples frozen in stone, and the moon keeps them. It keeps them with a kind of stubborn honesty. There's no atmosphere thick enough to burn incoming objects down into harmless sparks. There's no blanket of weather to soften edges. So impacts happen more directly, and their results persist longer. That means the moon is covered in craters of all ages, some softened by time, others crisp enough to look freshly stamped. If you picture a crater up close, it isn't just a dent. It's a landscape, a rim rising above the surrounding terrain. Slumped terraces along the inner walls where rock gave way and slid down after the blast. A floor that might be flat, or might hold a central peak, or might be flooded with older lava in some places. And then beyond the rim, an apron of debris, ejecta, thrown outward and spread across the surface. The ejecta can blanket nearby terrain, smoothing it in a thin layer, creating a subtle texture difference that's visible even from Earth if the crater is large and young enough. Those bright streaks you sometimes see, the rays, are part of that story. They're like the moon's signature flourish, the part where it says, yes, something happened here. Rays form when an impact throws out fresh material from beneath the surface. That material tends to be brighter because it hasn't been darkened by long exposure to space. Over time, those rays fade as the surface gets altered by countless tiny hits and particle bombardment. So rays are a kind of youth marker. The brighter and more distinct, the more recent the crater tends to be on the moon's timetable. You don't need to remember names, but names can make the whole thing feel more personal, like you're learning a familiar city's neighborhoods. Tycho is one of the famous ray craters, bright, bold, dramatic. Copernicus, too, with rays that stretch across the lunar face like pale veins. They're visible because they're relatively young compared to the moon's oldest terrains, and their ejecta still holds that fresh brightness. Then there are older craters, softened and worn, not by wind or water, but by time's quieter tools. Micrometeorites, tiny particles, pepper the surface constantly, churning and roughening the upper layer. Over enormous time, that gentle, endless sandblasting blurs sharp edges. New impacts overlap old ones, cutting into rims, filling floors with debris, turning once proud circles into partial ghosts. The moon doesn't erase, it layers. It's like a memory that doesn't fade so much as it gets covered by new memories. That layering is how scientists read time up there. You can look at an area with many overlapping craters and know it's old. You can look at smoother, less cratered terrain and know it was resurfaced later, often by lava flows. Crater counting becomes a clock of sorts, not precise to the day, but powerful over geological ages. More craters usually means more time exposed. Fewer craters usually means something renewed the surface later. The moon turns statistics into history, and the history has a gentle way of circling back to you. The same impacts that scar the moon were also happening to Earth, especially early on. Earth simply doesn't show you the receipts. The moon does. When you look at its cratered highlands, you're looking at a record of the environment Earth survived. It's like having an older sibling who kept a diary of the family's chaotic childhood while you moved on and forgot. There's also the small comfort of perspective. Most of the objects that hit the moon are not world-ending monsters. They're small. Many are tiny grains, bits of dust and rock. But because there's no air to slow them, even small things arrive fast enough to matter locally. A grain can strike like a microscopic bullet, creating a tiny pit, melting a speck of rock, kicking up a puff of fine material. Multiply that by billions of years, and you get a surface that's been gently, constantly worked, as if time itself were sanding it down with invisible hands. Every so often, a larger impact happens. You might imagine the moon as completely static, but it still takes hits. Most of them are too small to notice from Earth, but occasionally an impact flash has been observed, brief, faint, a tiny moment of light as rock vaporizes at the point of collision. It's not a fireworks show. It's more like the universe clearing its throat. The moon absorbs the event and keeps going, and the mark remains. It's hard not to feel a little calm about something that can take that kind of timescale violence and still appear serene. The moon looks peaceful because it is peaceful now, but it earned that peace in the slowest possible way, by enduring. It took the hits, cooled down, and held on to the evidence without complaint. The craters also give you a strange sense of permanence. On Earth, you can feel time as something that takes away. Things decay, things break, things are replaced. On the moon, time is more like a collector. It piles up events. It keeps the shape of them. The surface becomes a museum floor where every scar is labeled in the language of geology. Rim, ejecta, rays, terraces, peaks. You're lying in a room that will be different in a decade, and above you is a landscape that still holds shapes from billions of years ago. If you imagine standing there, just as a mental exercise, no need for an actual spacesuit fantasy, unless that's your thing. You notice how crisp everything seems. Crater rims cast long shadows. The walls drop steeply. The terrain looks sculpted, not softened. Even the smallest bumps and pits would feel like they've been waiting for you to notice them. It's a world where time is written in relief rather than in erosion. The moon doesn't smooth away its past. It displays it. And those impacts didn't just carve pits. They shaped the moon's larger architecture. Massive basin-forming impacts rearranged crust, created rings of mountains, opened pathways for lava to flood low areas later. The Maria, you recognized as dark seas, are connected to that violence. An impact creates a deep wound. Later, internal heat sends lava up to fill it like a slow, dark healing process. The moon's face is the result of those two forces working in sequence. Blow, then fill, scar, then settle. That sequence echoes the way your mind works at night. A sharp moment happens in your day. An argument, an email, a worry, and then the night comes along with its softer light and tries to fill the basin. Not erase it, Not pretend it didn't happen, but smooth it enough that it doesn't catch your thoughts like a jagged edge. Moonlight doesn't fix your day, but it changes the texture of it. It makes things less sharp. So the moon's craters become oddly reassuring. They're proof that even after huge impacts, the surface stabilizes. The rim remains. The story becomes part of the landscape. And the moon stays in orbit, steady enough to pull tides, steady enough to keep showing you the same familiar face, steady enough to turn ancient violence into a pattern that feels almost decorative. You can hold that image, the moon as a calm archive. Not a flawless sphere, but an honest one. A place where time doesn't sweep things away, it arranges them. A place where even damage becomes information. And while you rest under its borrowed light, sunlight on detour, you can let that long, quiet endurance settle your own thoughts into something softer, less urgent, more willing to be still. Stillness has texture up there, even if it doesn't look like it from here. The moon seems smooth and clean in the sky, like a polished button someone stitched onto the night. But the moment you imagine stepping onto it, the illusion falls apart in the most irritatingly fascinating way. The ground isn't rock the way you think of rock. It's not a solid slab you can trust. It's a layer of powdery, gritty, clingy stuff that behaves like it's been training for years to get inside your shoes, your zippers, your thoughts. That stuff is lunar regolith, moon soil, except it isn't soil the way Earth has soil, because Earth's soil is made with the help of life. Roots, microbes, rot, moisture, time, all mixing and softening and rounding. The moon doesn't do any of that. No worms, no leaf litter, no damp smell after rain. Just impact after impact, tiny and large, constantly breaking rock into smaller and smaller fragments until the surface becomes a blanket of crushed geology. And it's not soft in a friendly way. It looks like dust, but it's more like dust with opinions. The grains aren't rounded by wind or water because there's no wind or water to do the rounding. They're sharp, angular, jagged, microscopic little shards that never got sanded down. Imagine the difference between beach sand and crushed glass. Moon dust leans toward the crushed glass vibe, except it's sneakier because it can look harmless until it's already everywhere. The way it forms is a slow grind with occasional punctuation marks. Micrometeorites pepper the surface all the time, little grains moving at ridiculous speeds because nothing slows them down. Each tiny hit melts a speck here, fractures a grain there, stirs the upper layer like an invisible whisk. Over millions of years, that constant churning creates a mature regolith, deeper in some places than others. In the highlands, where the surface has been exposed longer, the regolith can be thicker. In younger volcanic plains, it may be thinner. Either way, the top of the moon is basically a long-term impact compost pile, minus the compost. There's also glass in it. Impact heat can melt small bits of rock. Then that molten splash cools quickly into glassy droplets and shards. Some grains are fused together into little clumps called agglutinates, tiny welded bits formed by micrometeorite impacts. So the regolith isn't just powdered rock. It's a messy mix of minerals, glass, and fragments, all processed by space like a kitchen with no chef, only explosions and time. And because the moon has no thick atmosphere, nothing behaves quite the way your instincts expect. On Earth, dust eventually settles because air and moisture help it clump and drop. On the moon, dust can cling through electrostatic charge. Sunlight and the solar wind can charge the surface. The dust grains can become electrically charged too, and charged dust is dramatic. It doesn't just fall and stay. It can lift, it can hop, it can stick to things as if it's offended you personally. This is where the moon starts sounding less like a romantic destination and more like a calm, beautiful place that would quietly ruin your equipment. Astronauts found that the dust stuck to boots, suits, tools, pretty much anything it touched. It worked its way into joints and seals. It scratched surfaces. It dulled visors. It refused to be brushed off neatly because it wasn't just sitting there like polite household dust. It was clinging, grinding, invading. The weirdest part is that the dust even had a smell, at least once it got inside the lunar module. Out on the surface, there's no air, so there's no smell traveling to your nose. But bring dust into a cabin with air, and suddenly your senses get involved. Astronauts described a scent reminiscent of things like burnt powder or spent fireworks. Not because the moon is burning, nothing is burning without oxygen, but because the freshly exposed surfaces of those grains are chemically reactive in a way Earth dust usually isn't. The moment that dust meets oxygen and humidity in a cabin, it reacts, and your nose interprets the result as a certain kind of sharp, dry odor. The moon, politely, waits until it's indoors to announce itself. You can picture the scene without turning it into a big, heroic movie moment. Just the quiet logistics. You walk, you kick up dust. It hangs lower and falls faster than on Earth because of the weaker gravity and no air drag. It doesn't billow like a cloud. It arcs and settles in graceful, slow parabolas like every grain is doing a tiny ballet, jump and landing. It looks beautiful. It is not your friend. Even footsteps become a lesson. On Earth, your foot compresses soil, pushes air and moisture around, and the ground rebounds. On the moon, you press into regolith that has been fluffed and fractured by impacts for ages. It compresses, holds the shape, and stays. The famous footprints look crisp partly because the dust is fine and partly because there's no weather to disturb them. A footprint can remain for a very long time, not forever. Micrometeorites will eventually soften everything, but long enough that outlasts empires isn't even a poetic exaggeration. The moon keeps impressions the way it keeps craters, quietly, stubbornly, without fuss. And that dust is part of why the moon feels so eerily still in photos. Without wind, there's no drifting haze. Without moisture, nothing clumps into mud. Without vegetation, nothing covers scars. Everything is exposed, sharp-edged, honestly itself. The dust sits where it falls. The shadows slice hard because there's no air to scatter light. If you wanted a planet designed to look like a high-contrast, black-and-white photograph, congratulations, the moon got there accidentally. There's a gentle mystery at the boundary between day and night on the moon too. The Terminator line, where sunlight hits at a low angle and shadows stretch long. Near that boundary, electrical charging effects may be stronger because one side is in sunlight and the other is in darkness, creating differences that can encourage dust motion. Some spacecraft observations have suggested a faint horizon glow at lunar dawn and dusk, possibly caused by dust particles suspended or lofted slightly above the surface, scattering sunlight. It's like the moon has a tiny, ghostly atmosphere made of dust that can briefly float, not because it wants to, but because electric forces are quietly playing with it. That image is strangely calming. Dust grains lifting in the low sun, glowing faintly at the horizon, then settling back down. It's not weather. It's not wind. It's a different kind of surface life, physics doing small, delicate tricks at the edge of light. And the moon dust is old in a way that makes old feel like the wrong word. Some grains have been sitting exposed for millions of years, being zapped by radiation, hit by tiny particles, altered at their surfaces. Space weathering changes the optical properties of the regolith over time, darkening it and reducing contrast. That's part of why fresh crater rays look bright. They expose material that hasn't been aged by space as long. Over time, the moon's surface gets a kind of patina, not from oxygen and moisture like metal on Earth, but from relentless micro-impacts and solar wind implantation. The moon doesn't rust. It tans in its own strange way. If your mind wants something playful to hold on to, imagine lunar dust as the universe's prank. Everything up there is silent, slow, beautiful, until dust shows up and behaves like glitter at a craft table. You don't remember inviting it, you don't know how it got there, and you'll still be finding it in places that make no sense. It's the cosmic version of that one tiny crumb that somehow ends up in the bed, even though you absolutely did not eat in the bed, because you're a responsible adult who would never do that. obviously. And because it's abrasive and clingy, it becomes one of the main practical challenges for any long-term activity on the moon. Rovers, habitats, solar panels, everything has to deal with dust. Panels can get coated and lose efficiency. Mechanical parts can grind. Filters can clog. Seals can wear. The moon's surface is like a beautiful clean room that is, at the same time, full of microscopic sandpaper. That's not a scary thought when you hold it gently. It's just a reminder that the moon isn't a dreamy postcard. It's a real place with real materials. A place that will not adjust itself for comfort. Humans have to adapt to it, not the other way around. And there's something soothing about that boundary. It takes the moon out of the realm of vague symbolism and places it back into the realm of honest physics. Rock, dust, charge, light. Even the color of the dust is more interesting than the moon's silvery reputation suggests. Up close, lunar regolith tends to look gray, sometimes with subtle brownish tones depending on composition and lighting. Under the harsh, direct sunlight on the moon, colors can look washed because the light is intense and there's no atmospheric scattering. Inside a habitat with softer lighting, the dust might reveal more nuance. The moon is not actually silver. It's your night-adapted eyes and your distant view that turn it into silver. Up close, it's a palette of grays and blacks and muted stone tones, like a charcoal drawing stretched across a world. That difference between what it looks like from here and what it is up there is part of the moon's charm. It keeps teaching you that perception is an instrument, not a truth. Moonlight feels romantic because you're seeing it through a human nervous system built for patterns, stories, and soft contrasts at night. The surface is romantic in a different way. Not soft but honest. Not smooth but patient. A place where even dust carries the signature of deep time. And if you're still smiling at the idea of dust behaving like glitter, keep it in your pocket for later, because it becomes a surprisingly good anchor when the moon's more dramatic moments arrive. In the meantime, the thought can settle in gently. The moon's quiet face is made of history ground into powder. A landscape of scars turned into grit, grit turned into a blanket, and that blanket holding footprints and crater rims the way a memory foam mattress holds the shape of your sleep. The idea of that dust, sharp, clingy, glitter with a grudge, stays in the back of your mind as your imagination lifts your eyes above the ground. Because once you stop staring at the moon's surface and you start paying attention to the space around it, the night changes texture again. On Earth, the sky is never truly empty. It's always filled with air, haze, moisture, tiny particles, the leftovers of weather and life. Even on a clear night, you're still looking through a thick ocean of atmosphere. Up there, the moon doesn't have that ocean, so everything looks sharper. Not just pretty sharp, but almost unsettlingly crisp, like someone turned the contrast up and refused to apologize. The same sunlight that becomes soft moonlight in your room would be brutal and clean on the moon, because there's no air to scatter it into a gentle wash. Shadows would not blur at the edges. They would slice. A rock could cast a darkness that looks painted on, with a boundary so definite your eyes might try to blink it into being softer. That black sky behind the moon isn't poetic black. It's practical black. There's no blue dome, no gradient, no glow from scattered sunlight. In daylight on Earth, the sky is blue because air molecules scatter shorter wavelengths of light all over the place, turning the whole atmosphere into a giant diffuser. On the moon, daylight happens under a sky that stays black. You could stand under full sun and still see stars, at least in theory, though in practice the brightness would overwhelm your eyes unless you shielded them. The point stays the same. Without air, the sky does not participate. It doesn't help. It doesn't soften. It doesn't make it nicer. It just sits there as a stark, silent backdrop. The moon is often described as silent, and that's not just a vibe. Sound needs a medium, air, water, something to vibrate through. On the moon, you can shout all you want and nothing carries. A scream becomes a private event. A laugh becomes a secret. Only vibrations through your suit and your body would exist, and any communication would have to be radio, not air. That kind of silence is so complete it feels almost too pure for human comfort. Earth is never that silent. Even in a quiet room, you can hear your own breathing, a distant hum, the slight click of a building settling. On the moon, the landscape doesn't hum. It doesn't whisper. It doesn't even pretend. And yet your mind keeps trying to add sound anyway, because it hates a vacuum almost as much as the vacuum hates sound. You imagine footsteps, and you can almost hear the crunch, except it wouldn't be the same crunch as earth dirt. No air means no crisp, familiar crackle. The regolith would compress, shift, scuff, and the only sound you'd hear would be inside your helmet through vibrations, like hearing your own steps through your bones. It would be intimate in the weirdest way, like the whole world has been muted and you're left with a soundtrack of your own body. That kind of silence changes how you perceive distance. On Earth, sound helps shape space. You can tell how far something is by how it echoes, how it fades, how it's absorbed. Remove sound, and space becomes purely visual, purely shadow, purely geometry. That's part of why moon footage can feel uncanny. The movement looks normal, but the environment feels like it's missing a layer of reality, because it is. The stars will be different too. Earth's atmosphere, while it makes sunsets gorgeous and breathing possible, also blurs the sky. It scatters light pollution. It twinkles stars by constantly shifting, tiny moving pockets of air bending starlight this way and that. Twinkling is a charming defect, like a singer with a raspy voice. On the moon, with almost no atmosphere, stars don't twinkle. They hold steady, sharp points of light pinned into black. The sky becomes more like velvet with needle pricks and less like a shimmering curtain. Even a moon itself would look different from up there. From Earth, the moon feels bright because you're dark adapted and because your atmosphere softens its glare. On the lunar surface, the sun is fierce, and the moon's surface reflects it harshly in a way that can make the ground bright enough to feel glaring. If you're standing in sunlight, the brightness isn't gentle, it's intense. And then you step into shadow, and it's not a bit darker. It's deep black, not romantic shadow, more like the power got cut. The temperature difference between sunlight and shadow can be extreme because there's no air to distribute heat. Sunlit ground bakes. Shadowed ground can be bitterly cold. Earth's atmosphere acts like a blanket and a mixer. The moon has neither. It's all direct input and direct loss. That creates a kind of visual trap that's quietly fascinating. Your eyes on Earth are used to shadows holding some detail because scattered light bounces around, because the atmosphere fills in darkness with a faint glow. On the moon, a shadow can hide detail completely. A crater interior could look like a black hole cut into the ground, not because it's bottomless, but because there's no stray light. Your brain sees darkness and starts inventing depth, mystery, danger. And the reality is just physics behaving honestly. So quiet can look sharp. Quiet can look like a hard-edged shadow. Quiet can look like the stars refusing to shimmer. Quiet can look like the sky staying black at noon. Earth's atmosphere is constantly telling little white lies to make the world feel softer. The moon doesn't do that. It shows you reality with fewer filters. And because you're a human with a human brain, meaning you're basically a bundle of stories wearing pajamas, you respond to that starkness by feeling awe. The moon feels more ancient in that setting, not because it changes age, but because it looks less touched. No clouds drifting by. No wind moving dust into dunes. No rain carving groups. No distant haze to soften the horizon. The landscape looks carved, placed, arranged. It can feel like a set built for something important, even though it's just rock and light. There's a reason the moon's horizon looks close, too. The curvature is stronger because the moon is smaller than Earth. You don't get the long, gradual curve you're used to. The horizon seems nearer. The landscape rolls away faster, and that makes the sky feel bigger. On Earth, you live under a blue canopy that feels like it wraps the world. On the moon, You'd feel like you're on a small stage beneath an endless black ceiling. That stage feeling is amplified by the lack of atmospheric perspective. On Earth, distant objects look bluer and lighter because air scatters light between you and them. Mountains fade into haze. Far trees soften. Distance has a visual signature. On the moon, distant features don't fade the same way. A ridge far away can look strangely crisp, as if it's closer than it is. Your eyes don't get the same cues, so your sense of scale can wobble. That's why photos can feel like they're missing depth. No haze means fewer depth hints. Your brain expects distance to blur, and when it doesn't, everything looks like it's pressed into a flatter image, even when it isn't. The moon also plays a quiet trick with time. A lunar day, sunrise to sunrise, lasts about a month in Earth time. That means daylight can linger for about 2 weeks, and night can linger for about 2 weeks. If you're imagining standing there, you're not thinking in morning, afternoon, evening. You're thinking in long, slow drifts of light. Sunlight crawls across the landscape. Shadows move like glaciers. The Terminator line, the boundary between day and night, slides across craters and plains with a patience that makes Earth's sunsets feel rushed. And that Terminator line is where the moon becomes most dramatic. When sunlight hits at a low angle, it exaggerates relief. Crater rims glow. Small bumps cast long shadows. The surface turns into a relief map of itself. Every ridge emphasized. It's the best time for a telescope view from Earth too, because shadows reveal depth. Full moon is bright but flatter. The Terminator gives you texture. It's a nice reminder that light isn't just illumination, it's information. Angle is everything. The same place can look calm or fierce depending on where the sun is sitting. That slow movement of shadow is also where your earlier dust thought can slide back in. With no wind to smooth anything over, the surface keeps its sharp little contours, its tiny pits, its scattered rocks. And yet dust still plays in its own quiet way, charging, clinging, sometimes lifting in that faint glow near the horizon at lunar dawn or dusk. It's not weather. It's not a breeze. It's like the moon has a microscopic, electric nervous system at the edge of light, barely noticeable unless you know to look for it. Even a famous Earth in the moon sky would look startling. From the moon, Earth appears large, much larger in the sky than the moon appears from Earth, because Earth is bigger. It would show phases too, waxing and waning, bright and dark. It would glow with blues and whites and browns, all the colors the moon lacks. And because the moon is tidally locked, Earth would hover in roughly the same place in the lunar sky, not rising and setting the way the moon does for you. Imagine that. A constant Earth hanging overhead, a steady marble that changes face slowly but never leaves. It's the ultimate night light for a world that otherwise has no atmosphere to soften anything. That image is quietly grounding. The moon sky is a place of hard edges, deep black, and sharp stars, but there would be Earth, bright, familiar, full of weather and swirling cloud bands and scattered sunlight. You're used to the moon being your companion. From the moon, Earth becomes the companion, and it would look alive. So the moon's lack of air is more than a scientific detail. It's an aesthetic. It's why everything there looks honest, high contrast, and strangely clean. It's why silence is not just heard but seen. It's why shadows feel like ink. It's why the stars don't flicker. It's why the moon's face, even from here, can look like it's been etched rather than painted. And as you sit with that, your mind begins to treat the moon less like a simple light source and more like a doorway into a different kind of night. One where the universe stops smoothing the edges for comfort and shows you its geometry with calm, unblinking clarity. That clarity can feel cold at first, but it also feels dependable. No weather surprises. No muffled distortions. Just rock, dust, light, and a silence so complete it turns the sky into something you can almost touch with your eyes. That clarity, that hard-edged honesty of light and shadow, makes it easier to imagine what it would feel like to be there, standing on a world that doesn't soften anything for you. And the moment you picture that, another thought settles in. The moon isn't only a landscape. It's also a place where humans have already been, and where the evidence of that visit doesn't get cleaned up the way it would on Earth. On Earth, you leave a footprint on a beach, and the next tide takes it personally. Wind smooths sand. Rain blurs edges. People walk over it. Time rubs it away until it's just a vague memory of a step. The moon doesn't do tides on its own surface. It doesn't do weather. It doesn't do that constant, gentle erasing that makes Earth feel alive and fresh. Up there, a footprint is an event that can linger with embarrassing confidence, like a text you sent years ago that still exists somewhere on a server, waiting to haunt you at 3 a.m. Those famous boot prints are pressed into regolith that behaves like powdered rock with sharp little corners. Your foot compresses it, pushes grains aside, and the edges hold because nothing comes along afterward to round them off. No breeze to blow dust back in neatly. No rain to soften and collapse the walls. No plant roots to disturb the pattern. The moon keeps the impression the way it keeps craters, stubbornly, quietly, without applause. Forever is too dramatic, though. The moon loves drama visually, with its ink-black shadows, but it's actually very patient about change. Over time, micrometeorites will pepper the surface and gradually churn the top layer. Grain by grain, impact by impact, the crispness of a footprint will soften. It's less like someone wiping it away and more like someone gently sanding it down with time itself. The point remains, that footprint will outlast you, your house, most human institutions, and probably several redesigns of your favorite app. There's something comforting about that permanence when you hold it gently. Not in a humanity is amazing motivational poster way. More like the universe is capable of keeping a secret without trying. The moon doesn't gossip. The moon doesn't judge. It doesn't care that humans arrived with cameras, experiments, and the general chaotic energy humans bring to any room they enter. It simply received the evidence and kept it. That makes the Apollo landing sites feel like quiet shrines, even if you're not the shrine type. Not because they're mystical, but because they're places where a brief, fragile, human moment got pressed into an environment that preserved impressions. The moon took the scene, boots, tools, tire tracks, little disturbed patches of dust, and wrapped it in stillness. Picture it. A ladder down to a surface that doesn't crunch the same way Earth dirt crunches because there's no air to carry sound. A step, a pause, the first movement of dust that hasn't moved that way in who knows how long. A gentle puff that arcs and settles in those slow parabolas because gravity is weaker and there's no atmosphere to make it billow. The silence is total, but inside the suit you'd hear your own breathing, your own heartbeat, the private soundtrack of being alive in a place that refuses to amplify anything. And because the moon is so visually unforgiving, every disturbed patch would stand out. A scuff mark isn't quickly blended into the surroundings. It's a signature on the surface, a line drawn in powder that stays where it was drawn. Even the most ordinary motion, turning, stepping, dragging a piece of equipment, becomes a mark in a long-term record. The moon's preservation doesn't only apply to footprints. It applies to everything left there. Bits of equipment, instruments, the paths where astronauts walked, the tracks from rovers, the little places where experiments were set down, the abandoned stages of ascent modules, the flags, which are their own quiet drama, because people love arguing about them more than they love thinking about vacuum and sunlight. Without air, a flag doesn't flutter. It just hangs in whatever shape it was left, stiffened by its support, gradually being bleached and battered by radiation and extreme temperature swings. And yes, there's a slightly uncomfortable joke buried in all of this. Humans visited the moon and left stuff. Of course we did. It would be out of character not to. We are the species that can't go to a park without leaving a snack wrapper somewhere. And suddenly we're surprised when we bring that energy to another world. The difference is that on the moon, you don't get a cleanup crew made of wind and rain. There's no natural reset. Whatever is left stays for a very long time. But if you let go of the modern guilt reflex for a second, there's also something quietly beautiful about the idea that the moon holds those artifacts like a time capsule. Earth changes too fast to preserve many moments cleanly. Cities rebuild, coastlines shift, materials rot, records get lost. The moon keeps a snapshot. It's like a museum display sealed behind glass, except the glass is vacuum, and the security system is nothing lives here to mess with it. There's a particular comfort in thinking about how small and human those sites are compared to the vastness around them. The moon's basins and highlands are enormous. Its craters range from tiny pinpricks to structures you could hide whole countries in. Against that scale, a footprint is almost absurdly delicate. A rover track is a faint line in powder, and yet those delicate marks remain, not because they're strong, but because the environment is so still. The moon doesn't reward strength. It rewards the absence of erasers. If you've ever felt like your own life gets overwritten too quickly, memories blurring, weeks sliding into each other, there's a strange relief in a place that doesn't overwrite. A place where a single step can last longer than a century of human arguments. The moon makes your timeline feel less aggressive. It slows your sense of urgency. It suggests that not everything has to vanish immediately. And then your mind wanders to the idea of distance again, because it's impossible not to. Those footprints are on a body roughly 384,000 kilometers away, sitting under a black sky that doesn't twinkle, on a surface covered in sharp dust that behaves like glitter if glitter had a personal vendetta. You're lying in a room with breathable air and probably a charger nearby, thinking about marks left in a place that doesn't even have wind to move them. The contrast is almost funny. The moon also keeps secrets in a more literal sense. Because it's tidally locked, those famous sites are all on the near side or near enough to it, where communication with Earth is straightforward. The far side stayed unseen by human eyes until spacecraft circled around and showed it to us. That means there are landscapes on the moon that no human has stood in, no human has disturbed, no human has marked with a footprint. It's not that they're mysterious in a supernatural way. They're mysterious in a simple way, untouched by us. That untouched quality is part of why the moon can feel safe as a symbol. It's close enough to be familiar, distant enough to be beyond daily drama. It doesn't get pulled into your mess unless you go out of your way to drag it in. It just hangs there, keeping its own time. And even on the near side, the moon keeps your secrets in another sense. It keeps them without reacting. People have projected fear onto the moon, romance onto the moon, omens onto the moon, poetry onto the moon. None of that changes its orbit by a millimeter. None of it makes it brighter or dimmer. You can imagine whispering a worry to the moon, and it wouldn't answer, but it also wouldn't judge. It would simply continue reflecting sunlight on detour, pulling oceans into their slow, breathing rhythm, showing you the same face because gravity trained it to. There's an odd mental comfort in that neutrality. So much in life responds. People react, sometimes unpredictably. Systems change. Plans slip. The moon doesn't respond emotionally. It doesn't escalate. It doesn't misunderstand you. It just exists. The silence you imagined earlier becomes a kind of emotional silence too. Space where your thoughts can land without being immediately bounced back by someone else's expectations. And while the moon holds those Apollo echoes, it also holds an even older record that makes the human record feel like a blink. Craters layered over craters. Lava plains filling ancient wounds. Rays fading over time. Dust slowly maturing under space weathering. Footprints are just the newest kind of mark, the most delicate kind of disturbance, sitting on top of a surface that has been accepting disturbances for billions of years. The moon's patience makes your own place in the story feel smaller, but not in a humiliating way. In a soothing way. You're not required to control everything. You don't have to be the main character of the universe tonight. You can be a quiet observer under a steady light, letting the idea of those preserved footsteps settle your thoughts into something calmer. And somewhere in that calm, you might find yourself smiling at the absurd tenderness of all. Humans traveled across a void, stepped on a powdered rock, left marks that could outlast nations, and then came home, while the moon stayed put, holding the scene like a memory it never asked for, but never discarded either. The thought of those preserved footprints stays with you in a surprisingly personal way, because it turns the moon from a distant object into something that has already touched human time. Not physically touched you, obviously. It's not that kind of channel. But it has touched the way humans count, the way humans plan, the way humans tell stories to themselves when the night gets too quiet. You live on a planet that spins fast enough to give you days, and circles a star to give you years. But the moon slides into that system like a third hand on the clock, slower, steadier, and just different enough to mess with your sense of rhythm in the gentlest way. You can almost feel it in language. Month, moon. They're basically cousins who grew up in the same house and still wear the same family nose. The moon cycle is one of the oldest repeating patterns people noticed that wasn't tied directly to the sun. If you don't have an app, if you don't have a printed calendar, if you don't even have numbers the way we use them now, you can still watch the sky and see a dependable change. A thin crescent that fattens night by night, a half-lit face, a near full glow that brightens the world, then the slow thinning back to darkness. It's like the night itself is breathing in a longer rhythm than your day. That rhythm, the one your eyes actually experience from one new moon to the next, is about 29 and a half days. Not a clean 30, because the universe refuses to make your schedule inconvenient. That's the synodic month, the cycle of phases. The moon is orbiting Earth, yes, but Earth is also orbiting the sun. So the moon has to travel a little extra to line up the same way again relative to sunlight. If you track the moon against the background stars instead, the orbital period is shorter, about 27.3 days. That's the sidereal month. Two different clocks measuring two different relationships, moon to stars and moon to sun as seen from Earth. It's the same moon doing the same orbit, but the reference point changes and suddenly your brain has to admit that month isn't one simple thing. There's something calming about that complexity because it's quiet complexity. It's not loud. It doesn't demand you solve it. It just sits there like a gentle puzzle you can hold and turn your mind while your breathing slows. The moon isn't rushing to make sense for you. It's content to be correct. Humans, of course, looked at that cycle and immediately tried to build life around it. Lunar calendars show up across cultures because the moon gives you visible checkpoints. You don't need instruments to see a new crescent. You can literally look up and know a new cycle is starting. That's powerful when you're trying to organize planting, travel, ceremonies, fasting, feasts, anything that needs shared timing. The moon became a public clock in the sky. But lunar months don't fit neatly into solar years. And that mismatch is where you can almost hear ancient people sighing. 12 lunar months are about 354 days, shorter than the solar year. So a purely lunar calendar drifts through the seasons. Your spring festival slowly slides toward winter if you don't correct it. Some cultures embrace that drift. Others added adjustments. Extra months inserted now and then to keep the lunar cycle aligned with the seasons. The math is patient, the solutions are clever, and the whole thing is oddly reassuring. People have always been trying to reconcile different rhythms, and nobody ever completely wins. You just get better at dancing with a mismatch. That dance shows up in your body, too, at least in the way you talk about your body. The moon has been linked to human cycles for so long that it's almost impossible to separate observation from myth. People noticed that the average menstrual cycle is roughly similar in length to a lunar month, and the story practically wrote itself. The moon became a symbol for fertility, for monthly change, for hidden tides inside the body. The symbolism is old and wide and beautifully persistent. Scientifically, it's more complicated and not nearly as tidy as the poetry wants it to be. Human cycles vary a lot. They don't lock neatly to lunar phases in a universal way. It's not a synchronized, planet-wide choreography where everyone's biology follows the same sky clock. But the fact that people even looked for that link tells you something. The moon invites pattern making. It invites you to search for rhythm. And then there's the moon's reputation for messing with your mind. Lunacy literally comes from luna, the Latin word for moon, and the idea that a full moon can stir madness has been hanging around for ages. You'll find in old beliefs, old medical writings, old superstitions. It's one of those cultural echoes that refuses to fully die because it's just dramatic enough to be satisfying. You have a weird night, you feel restless, you can't sleep, and the moon is sitting up there like a perfect scapegoat with a glowing face. It's also the perfect villain for stories. Werewolves, curses, strange behavior, the full moon as a trigger, a switch flipped in human blood. It's such a strong image that even people who don't believe it still kind of enjoy believing it for 5 minutes, like wearing a costume at a party and pretending it's your real personality. The calmer truth is that the moon's most direct influence on you is light and timing, not magic. A bright full moon can make nights less dark. That matters if you don't have curtains, or if you sleep outdoors, or if your environment is sensitive to small changes in illumination. Humans evolved under natural cycles of light and dark. For most of our existence, the full moon wasn't just pretty, it was practical. It made travel easier. It changed hunting. It altered how visible you were to predators and other humans. It made the night less private. Even now, in a world where you can turn on a lamp with a finger tap, light still sneaks into your biology. Your brain uses light cues to help regulate circadian rhythms. Darkness encourages melatonin production. Light, especially bright light, can suppress it. So it's not crazy to think that a brighter night could nudge sleep. The effect might be small, and it won't hit everyone the same, but the mechanism is simple. Your body responds to light because your body has always responded to light. That's where the moon's reputation gets a tiny bit of scientific mercy. Some studies have found subtle changes in sleep around full moon periods, like slightly reduced deep sleep or longer time to fall asleep, while other studies don't find strong effects or find effects that are inconsistent. Human sleep is messy. Stress, screens, caffeine, temperature, noise, schedules, hormones. Your brain have a long list of reasons to be dramatic at bedtime, and the moon is only one gentle variable among many. The moon doesn't need to be a supernatural force to still be a factor in certain conditions. It can simply be brighter, and brightness can matter. And if you want a little gentle sarcasm to tuck in here, the full moon is often blamed by people who spent 3 hours scrolling under a bright rectangle and then acted shocked when their brain refused to power down. It's not that the moon did nothing. It's just that your phone did a lot. Still, there's something soothing in realizing that people have always tried to explain sleepless nights with sky stories. Before anyone could say circadian rhythm, they said the moon is acting up. Before anyone could measure hormones, they measured feelings. It's human. It's the same impulse that sees a face in the moon's Maria and highlands. The same impulse that made seas out of lava plains. Your mind wants the night to have meaning. It wants your restlessness to have a cause you can point at. A bright moon is at least a beautiful cause. The moon also shaped human timekeeping in a deeper way through tides, which you've already felt in the background like ocean breathing. Coastal communities didn't just use the moon to mark months. They used it to predict water. Fishing rhythms, shellfish gathering, navigation. Tides are a clock you can't ignore if your livelihood depends on the shoreline. And even beyond humans, countless creatures treat lunar cycles like instructions. Some coral species spawn in coordinated events timed to lunar phases. Certain fish and marine animals synchronize behavior with tides and moonlight. It's not that the moon is commanding them. It's that the moon creates a reliable environmental pattern. Light levels, tidal height, current strength. And life learns to use reliability the way you use an alarm. That reliability can be comforting for you too, even if you never go near the sea. You're surrounded by rhythms you didn't create. The day-night cycle. The weekly pattern society forces on you. The month ticking by in paychecks and bills and birthdays. Underneath all of that is a lunar rhythm that doesn't care about your deadlines and doesn't change because you're stressed. It's steady in a way that feels almost unfairly calm. If your mind drifts back to those footprints again, it's the same theme. The moon preserves patterns. It keeps marks. It keeps time. Even the dust, glitter with a grudge, keeps time in its own way, slowly altered by space weathering, slowly darkened, slowly matured. Everything up there is a clock if you know what you're looking at. Crater counts, ray brightness, regolith depth. The moon is basically a timepiece made of rock. And you, lying here, are another kind of timepiece. Your heartbeats, your breathing, the subtle shifts of your nervous system as you relax. Your body also keeps rhythm. It has cycles inside cycles. Some are tied to the sun. Some are tied to habit. Some feel mysterious because you can't see the gears. The moon, hanging quietly over your world, becomes a mirror for that idea. Not a mirror of your face, but a mirror of your need for rhythm. So the next time you hear someone say, with total confidence, that people go crazy during a full moon, you can hold two truths at once without needing to fight about it. One truth is that the moon has been blamed for human behavior for centuries because humans love a dramatic sky story. The other truth is that brighter nights can subtly affect sleep and activity patterns in ways that are real, even if they're not mystical. The moon's influence is quiet and physical, not theatrical and cursed. The theater is ours. That's the relaxing part. The moon doesn't need to be a spell. It could be a lamp, a clock, a tide maker, a rhythm you can feel indirectly. It could be a steady object that helped humans invent months, build calendars, tell stories, and explain insomnia long before anyone had the words to describe brain chemistry. It's a companion that shaped your language and your timekeeping simply by existing where it exists. And as you sit with that, the moon's cycle stops being a background fact and becomes something you can almost sense as a gentle gear turning. Phases shifting, tide bulges moving, calendars drifting and correcting, sleep myths blooming and fading, while your own internal rhythm slows toward rest, not because of superstition, but because your body recognizes the quiet logic of a night governed by steady motions. That quiet logic of steady motions starts feeling even more satisfying when you notice the moon has a habit of acting like it's holding eye contact. You look up night after night, month after month, and it keeps showing you the same familiar face. Those dark seas that aren't seas, the bright highlands, the ray-streaked craters like someone flicked pale paint across charcoal. It's so consistent that it can feel like the moon is choosing to face you, like it has manners. It's not manners. It's gravity being clingy in the most long-term way imaginable. The moon rotates, but it rotates at exactly the pace it orbits Earth, so one spin takes about one orbit. That's why the same hemisphere is turned toward you most of the time. It's called tidal locking, and it's one of those concepts that sounds like it belongs in a romance novel until you realize it's basically the universe's version of friction slowly rearranging things until they stop being dramatic. Early on, the moon likely spun faster, but Earth's gravity raised tidal bulges on it, little stretches in its shape, because even rock can flex a bit when gravity keeps poking it in the same way. Those bulges didn't stay perfectly lined up with Earth at first. The moon would rotate, the bulge would get tugged, and that tug would act like a brake. Over an absurd amount of time, that braking stole rotational energy and smoothed the moon into the calmest possible relationship with Earth, one where it always shows the same face. You can picture it as the moon deciding to stop fidgeting. It had a restless phase, it got gently scolded by gravity, and eventually it settled into a single, stable posture. The irony is that the moon settling down is what makes it feel like a constant companion. You don't get a different view every night, the way you would if it spun freely. You get consistency. You get a face you can recognize from childhood, the same face that holds those preserved footprints and that dust that clings like glitter with a grudge. But here's where the moon gets a little playful. Even though it's tidally locked, it doesn't hold that face perfectly still. If you pay attention over time, or if you've ever watched a detailed animation, you'll notice the moon seems to rock and nod slightly, like it's dozing but still listening. That gentle wobble is called libration, and it's the reason you can actually peek a bit around the edges. You're not stuck seeing exactly 50% of the moon. Over time, you can see about 59% from Earth, because the moon gives you these tiny glimpses of what's just around the limb, as if it's turning its head a fraction to show you a little more, then returning to its usual calm expression. The first kind of libration feels like a slow side-to-side twist, and it happens because the moon's orbit isn't a perfect circle. It's an ellipse, just slightly stretched, so sometimes the moon is a bit closer to Earth, and sometimes it's a bit farther. As it travels along that ellipse, it moves faster when it's closer and slower when it's farther, because gravity doesn't do equal speed commuting. But the moon's rotation rate stays fairly steady. The result is that at certain points in its orbit, the moon rotates a little ahead or behind compared to its orbital motion as you see it, and you end up seeing slightly more of the eastern edge for a while, then slightly more of the western edge. It's like watching someone on a carousel who is trying to face you the entire time. They do, mostly. But if the carousel speeds up a bit on one side and slows down on the other, and their body rotation stays steady, you get moments where you see more of one cheek than the other. That's libration and longitude, and it's one of those quietly elegant ways the universe reminds you that same face doesn't mean perfectly frozen. The second kind of libration is more like a nod up and down, and it comes from tilt. The moon's rotation axis isn't perfectly upright relative to its orbit around Earth. It leans a bit, around 6.5 degrees relative to its orbital plane, which is enough to let you see slightly over the top at one time and slightly under the bottom at another. So across a month, the moon appears to bow its head toward you and then lift its chin away, offering a peek at regions near its poles that would otherwise stay just out of view. That tilt also ties into why the moon's polar regions are such a quiet source of fascination. Those areas can have craters near the poles that never see sunlight on their floors because the sun stays low on the horizon there. In the moon's world of harsh light and ink-dark shadow, those permanently shadowed spots can be unbelievably cold, like pockets of night that never end. Even thinking about them feels like touching a cold metal railing in the dark, sharp, real, and strangely thrilling. But the important feeling tonight is simpler. The moon doesn't just face you, it subtly nods. There's a third kind of libration that's almost unfair because it's not really the moon moving at all. It's you. As Earth rotates, you observe the moon from slightly different points on Earth's surface, sometimes from the left side of Earth, sometimes from the right, depending on the hour. That changes your viewpoint just enough to let you see a tiny bit around the moon's edge one way and then the other, like moving your head side to side to peek around a door frame. That's called diurnal libration. And it's a reminder that even when you think you're being still, you're riding a spinning planet while staring at a world that's falling around you in orbit. All three of these motions together give the moon that gentle rocking quality. Side to side, up and down, a slight shift because your vantage point changes. If you ever wanted proof that steady and moving can be the same thing, the moon is basically performing that lesson on a loop. This is also where the moon's distance becomes a quiet part of the show again. Because of its elliptical orbit, the moon's apparent size in your sky changes a little. When it's closer, near perigee, it looks slightly larger. When it's farther, near apogee, it looks slightly smaller. The change is real, but your eyes are not great at noticing it without a comparison photo or without the moon sitting near the horizon playing that old perception trick on you. Still, there's something calming about knowing the moon's steadiness includes a gentle in and out breathing motion in space. And there's a deeper layer of wobble that happens over longer time scales too. The moon's orbit is tilted relative to the plane of Earth's orbit around the sun by about 5 degrees. That tilt is why the moon doesn't cause an eclipse every month. Most months, the alignment isn't precise enough. But the tilt also means the orbit has nodes, crossing points where it intersects Earth's orbital plane, and those nodes slowly shift over time. You don't need to chase the math. The feeling is enough. The moon's path isn't a fixed hula hoop. It's more like a gently rotating hoop, slowly turning its orientation as years pass. If you let your mind sit with that, the moon becomes less like a static ornament and more like a living piece of clockwork. Not living as in breathing and thinking, but living as in constantly moving through a pattern that never stops. Orbiting, rotating, wobbling, nodding, and doing it all without needing your attention, which is, frankly, the kind of friend you want at night. There's something quietly intimate about tidal locking, too, once you think about the consequences. Because the moon shows you the same face, you build familiarity. The Maria become a recognizable pattern. The bright highlands become the edges of that pattern. The big dark spread of Oceanus Procellarum becomes a familiar blot. The crisp, bright rays of Tycho become a signature. You learn the face the way you learn a friend's expressions, without trying, just by seeing them often enough. The far side, meanwhile, remains the moon's private self. It isn't dark permanently. That's a common misconception, because the moon rotates and the sun shines on every part over time. It's far because it faces away from Earth. It's the face that doesn't have the big, dark Maria spread across it in the same way. The face that looks more heavily cratered and bright, more like pure highlands. The near side is the one with the drama of dark plains. The far side is the one with the quiet accumulation of scars. And yet, because of libration, the far side isn't completely hidden. It teases. It lets you glimpse just around the edge, as if it's reminding you it's there. That teasing is part of the moon's charm. It's close enough to feel knowable, but it always keeps a margin of mystery. You can map most of it now with spacecraft, of course, but emotionally, it still feels like a secret. That emotional effect is grounded in something very real about how humans bond with patterns. Repetition builds comfort. A steady face in the sky builds a sense of companionship. The moon doesn't chase you, doesn't change on your command, doesn't react to your day. It simply keeps showing up, and over time, your brain starts treating that as a kind of safety signal. Consistency is calming, even when it's coming from a sphere of rock covered in abrasive dust that would absolutely ruin your favorite jacket. And because the moon rocks a little rather than staying perfectly fixed, it doesn't become boring. It stays familiar without becoming flat. The edges shift. The orientation changes subtly. Sometimes the moon seems tilted one way, sometimes another, because its orbit and its position in the sky change the angle you see. If you've ever noticed the moon looks lying on its side, like it's too tired to stand up properly, you're seeing the geometry of your viewpoint and the moon's orbit interacting. It's not the moon being lazy. It's you watching a moving system from a rotating platform. That's the beauty of it. You're not looking at a painting. You're looking at a mechanism. A gentle mechanism, but still a mechanism full of tiny motions that layer together into something that feels steady from far away. You're watching gravity do choreography. So while you rest under that pale light, you can hold the moon in your mind as a partner in slow movement. It faces you because it was trained into that posture by tides. It nods and rocks because orbits are not perfect circles and axes are not perfectly upright, and your own planet insists on spinning under you. You see a little more than half over time because the universe isn't a strict gatekeeper. It's a patient one, revealing just enough extra to keep you curious, not enough to make the mystery disappear. And that curiosity stays soft. It doesn't sharpen into urgency. It just glows in the background, steady as moonlight, faint as earthshine on the dark part of crescent, making your thoughts feel less like a swarm and more like a slow, gentle turning. That slow rocking and nodding of the moon keeps you feeling like you're watching something alive, even though it's just gravity doing its patient work. And once you start thinking in that calm mechanical way, tilts, angles, steady motion, the night offers you one of its cleanest miracles. The moments when everything lines up so perfectly that the universe looks like it planned it, even though it absolutely did not. An eclipse is basically geometry wearing a dramatic cloak. You're on Earth, turning beneath the sky, and the moon is circling you, and the sun is blazing far away like it owns the place. Most of the time, those three bodies are not in a perfect line. They're close, but not exact, because the moon's orbit is tilted relative to Earth's path around the sun. That little tilt, just a handful of degrees, is enough to save you from living in a constant eclipse schedule, which sounds romantic until you remember humans can't even coordinate a group dinner without chaos. So most months, the new moon passes a little above or a little below the sun from your viewpoint. The full moon passes a little above or below Earth's shadow. The system is almost aligned, but not quite. The moon keeps doing its calm, face-holding routine, nodding a bit with libration, sliding around Earth, and nothing special happens beyond the usual phase changes that already feel like a quiet heartbeat. Then, on certain windows of time, the moon crosses the line where alignment becomes possible. Those windows are called eclipse seasons, and they're basically the times when the sun is near one of the moon's orbital nodes, those crossing points where the moon's tilted orbit intersects the plane of Earth's orbit around the sun. If that sounds like a mouthful, it's just this. There are moments when the moon's path lines up with the sun-Earth line in a way that makes shadow games possible. Shadow games, but with standards. When a moon passes in front of the sun from your perspective, that's a solar eclipse. When a moon passes through Earth's shadow, that's a lunar eclipse. Same trio, different ordering. It's like the universe rearranging three objects on a table and pretending it's a brand new trick. And honestly, it kind of is, because the scale is so absurd that the fact you can see it at all feels like a private favor. The weird coincidence that makes eclipses feel so clean is that the moon and the sun appear almost the same size in your sky. That's not because they're the same size. The sun is enormous compared to the moon. It's because the sun is much, much farther away. The sun is roughly 400 times wider than the moon, and it's also roughly 400 times farther from you than the moon is. That balance means their apparent diameters match closely enough that the moon can cover the sun's face with eerie precision. That precision is what turns a solar eclipse into something that feels unreal. The moon doesn't just pass in front like a coin drifting across a flashlight. It can cover the sun so neatly that daylight changes character. The sky deepens, shadows sharpen and become strange. The world looks like someone lowered the saturation on reality. But the coverage depends on distance too, because the moon's orbit is elliptical. Sometimes the moon is nearer, looking a bit larger. Sometimes it's farther, looking a bit smaller. When it's nearer and the alignment is perfect, you can get a total solar eclipse, where the sun's bright disk is fully hidden and you can see the sun's corona, its outer atmosphere, glowing around the moon like pale, delicate hair. When the moon is farther, it might not fully cover the sun, and you could get an annular eclipse where a ring of sunlight remains visible around the moon. A ring of fire. Not fire you can touch, obviously, but the kind that makes your brain go quiet because it can't quite accept what it's seeing. And then there are partial eclipses, where the moon takes a bite out of the sun, but doesn't cover it completely from your location. The sun becomes a bright crescent, like it's borrowing the moon's aesthetic for a while. That bite effect is very real, very clean, and also a good moment to remember that staring directly at the sun is not a brave personality trait. The sun doesn't care about your curiosity. It will happily damage your eyes without even noticing you were there. Eclipses are a reminder that beauty and safety don't always share a calendar. The moon's shadow during a solar eclipse isn't huge. That's part of the thrill. You might imagine a giant shadow blanketing half the planet, but the darkest part, the umbra, is a narrow cone. It can sweep across Earth's surface like a moving spotlight. The area that sees totality is often a relatively thin path, sometimes only a couple hundred kilometers wide. Outside that path, you still see an eclipse, but but it's partial because you're in the penumbra where only part of the sun is blocked. That difference between umbra and penumbra is like the moon's version of those soft shadows you noticed in Moonlight, except here the shadow has teeth. The umbra is the full blackout zone. The penumbra is the almost zone. And because Earth is turning and the moon is moving in its orbit, that shadow doesn't sit still. It glides. It races. It makes its own schedule across continents. And you either happen to be under it or you don't. Most humans, most of the time, aren't. Which is why total solar eclipses feel like rare visitors. They don't come to you often, and they don't stay. Lunar eclipses are different in personality. They feel slower, more patient, less like a spotlight, and more like a gradual shift in mood lighting. Instead of the moon casting a shadow on you, you cast a shadow on the moon. Earth does, anyway, since you're riding it like a passenger on a spinning ship. During a lunar eclipse, the moon moves into Earth's shadow. That shadow is much larger than the moon, so the event can be seen from anywhere on the night side of Earth where the moon is above the horizon. It's less picky about geography than a total solar eclipse. You don't need to stand in a narrow corridor on a map. You just need to have the moon in your sky and the alignment cooperating. Earth's shadow has layers too. There's the penumbra, where Earth blocks some sunlight, and the moon dims slightly, sometimes so subtly you might miss it if you're not paying attention. Then there's the umbra, the deeper shadow, where direct sunlight is blocked much more strongly. As the moon slides into that darker region, it can look like someone is slowly turning down the brightness on a familiar face. The edge of shadow creeps across lunar craters and plains, and because the moon's features are so sharp, you can see the curvature of Earth's shadow clearly. It's one of the simplest proofs that Earth is round that you can watch happen in real time, quietly, without anyone arguing in your comment section. And yes, the moon can change color during a lunar eclipse. It can take on a dim, unusual tone rather than disappearing completely. Your brain registers it as something ancient and ceremonial, because it looks like the moon is being transformed rather than simply shaded. The reason for that color shift is one of the loveliest pieces of atmospheric physics you'll ever get to hold in your mind, and it deserves its own slow moment later. So you just keep the image for now. The moon and Earth's shadow, dimmed but not gone, like a familiar face seen through a curtain. What makes eclipses especially satisfying is how much of it you can explain with simple shapes. Circle of Sunday, circle of moon. Circle of Earth's shadow. The way those circles overlap in a calm, predictable way. Predictable because the orbits are stable and the geometry repeats. It's not random magic. It's scheduled alignment. And yet it still feels magical because the scale and the precision are far beyond anything your daily life asks you to imagine. Even the scheduling has its own lullaby rhythm. Eclipses tend to happen in seasons because of those nodes. Roughly every 6 months, there's a window where the alignment between the sun and the moon's orbital plane makes eclipses possible. You can have a solar eclipse near new moon and a lunar eclipse near full moon in the same season, depending on exact alignment. Sometimes you get one eclipse, sometimes two, sometimes a run of several. The universe keeps a calendar, but it's a calendar written in angles and periods rather than in the kind of neat boxes you hang on a wall. Over longer time, patterns repeat in a way that feels like a secret handshake. There's a cycle called the Saros, about 18 years and some extra days, after which similar eclipse geometry returns. Similar, not identical, because Earth's rotation and the exact position shift, but similar enough that eclipses echo across generations. That means an eclipse can have relatives. A total solar eclipse in 1 year can have a sibling 18 years later that looks similar but appears over a different part of the world. It's like the universe leaving repeating motifs in its music. And that repeating music is grounded in the moon's slow drift outward too. The tidal exchange you were already holding in your mind. The moon is gradually moving away from Earth. That affects eclipses over immense time scales. In the far future, total solar eclipses will become rarer and eventually impossible, because the moon will appear slightly smaller in the sky and won't be able to cover the sun completely. That is such a ridiculous thought that it almost feels rude to mention at bedtime. The idea that the kind of eclipse that can turn day into a hush is, in the longest view, temporary. But it's also comforting in a strange way. It means you live in a sweet spot of cosmic timing. The moon is at a distance where it can create this perfect fit. The sun is at a distance where it appears just the right size. The tilt is just enough to make eclipses rare rather than constant. Everything is balanced in a way that gives you occasional, memorable moments without turning them into background noise. Eclipses also make you notice how shadows behave when the light source changes shape. During a solar eclipse, sunlight isn't a full bright circle anymore. It becomes a crescent. And that changes the way light filters through small gaps. If you've ever seen tiny crescent shapes projected on the ground through leaves during an eclipse, that's not a camera trick. Each little gap between leaves acts like a pinhole projector, forming an image of the sun's current shape. Under eclipse light, the world starts making miniature suns on sidewalks and walls. It's one of those details that feels like the universe is showing off, gently, without needing to raise its voice. Even the temperature and the behavior of animals can shift during a strong solar eclipse, because the light level drops and the environment gets confused. Birds may settle as if evening arrived early. Insects might change their rhythm. People often get quiet too, not because anyone told them to, but because the nervous system recognizes something deeply unusual about midday turning into twilight. It's the same calming effect you felt from moonlight reducing visual noise, except amplified and sharpened into a moment that feels ceremonial. So you lie there, thinking about alignments that don't need belief to be beautiful. Just three bodies moving on steady paths, sometimes sliding into a line, so clean it makes your world look freshly drawn. The moon that nods at you with libration, that keeps its dust like glitter with a grudge, that holds footprints like a private archive, also becomes the object that can cover the sun with eerie precision or drift into Earth's shadow with slow grace. And the mystery deepens not because you don't understand it, but because you do. Understanding doesn't flatten it. It makes it richer. It gives your mind more edges to hold gently, more quiet gears to watch turning. Geometry becomes wonder. Shadow becomes choreography. And you can feel the night expanding around that idea. An orderly, magnificent universe that occasionally aligns its lights and bodies just so, then returns to its steady motion as if nothing special happened at all. That neat, indifferent geometry of eclipses is already enough to quiet your mind. But a lunar eclipse has one extra trick that feels like the universe slipping you a private message. You expect shadow to mean absence. You expect the moon to go dull, maybe even vanish. Instead, at the deepest part of some lunar eclipses, the moon changes color. It doesn't disappear. It blushes. People call it a blood moon, which sounds like the sky is trying to start drama. The reality is calmer and, somehow, even more beautiful for being explainable. The moon turns coppery, brick red, sometimes smoky orange, sometimes a deep rust like an old coin found in a drawer. And you're seeing that color for a reason that is both simple and quietly mind-bending. You're seeing Earth's sunrises and sunsets, wrapped around the planet's edge, spilled onto the moon. During a lunar eclipse, the moon moves into Earth's umbra, the region where Earth blocks direct sunlight. If Earth had no atmosphere, the moon would drop into that shadow and go much darker, almost as if someone lowered it behind a curtain. But Earth wears air, and air is not just something you breathe. It's a lens and a filter. Sunlight doesn't stop cleanly at the edge of Earth. Some of it schemes through the atmosphere, gets bent, and gets redirected into the shadow. So while the moon is in shadow, it's also being lit by sunlight that took a longer, stranger route. That route is the same one that makes your evenings warm-colored. When sunlight travels a long, slanted path through air, shorter wavelengths, blues and violets, get scattered more strongly. The blue gets peeled away and flung around the sky, leaving the beam itself richer in reds and oranges. That's why the day fades into gold and then into ember. During a lunar eclipse, Earth's atmosphere does that filtering along the planet's rim, and the remaining warm light is what reaches the moon. The bending part is refraction, and it's the detail that makes the whole thing feel like a gentle optical trick. Earth's atmosphere is layered, thicker near the surface, thinner higher up, so light passing through it changes direction slightly. Sunlight grazing Earth's edge gets nudged inward, toward the shadow, as if the planet is quietly guiding a thin ribbon of day into night. Not enough to make the moon bright again, but enough to keep it visible and tinted. That's why totality often looks like an ember rather than a blackout. The moon becomes dim, but it's still readable. You can still sense the familiar pattern of Maria and highlands inside the glow, like the face you've been watching all night is suddenly seen through warm glass. Those basalt plains that looked like ink earlier deepen under copper light. The brighter highlands become softer highlights, the edges still crisp against black, because the moon never learned how to blur. The exact shade isn't always the same, and that's part of the charm. Earth supplies the filter, and Earth's atmosphere changes. If the air around the planet's limb is clear, more light makes it through cleanly, and the eclipsed moon can look brighter, more orange, more honeyed. If the atmosphere is loaded with particles, dust, smoke, pollution, volcanic aerosols, then sunlight gets scattered and absorbed in different ways, and less of it reaches the moon. The eclipse can look darker, deeper red, sometimes almost brownish, like the glow has been turned down while the color stays. That detail is strangely intimate. A blood moon is not only a moon event, it's an atmosphere event. You're seeing the state of Earth's air written into light. The moon becomes a screen, and Earth's edge becomes a projector, and the image is the color of filtered sunlight. Earlier you held the idea of Earthshine, Earth softly lighting the moon's night side. This is Earthshine, but upgraded. Not reflection, but refraction, and not a pale gray whisper, but a warm, smoky glow. There are subtle chemical fingerprints in the mix, too. Ozone can absorb particular wavelengths and nudge the color in delicate ways. And the light doesn't pass through one single uniform slice of atmosphere. It samples different altitudes and different conditions around the rim of the planet. Imagine all the dawns and dusk happening at that moment around Earth's edge, over oceans, deserts, storm systems, cities, each one contributing a slightly different tint. The moon gathers that patchwork and hands it back to you as one calm disk. Even the way the moon enters the shadow helps the feeling. Earth's shadow has layers, a softer penumbra and a darker umbra. The dimming begins gently, like a slow fade rather than a switch. A curved bite of darkness creeps across the lunar surface, and because the moon's features are so sharp, you can watch that curve with a kind of quiet satisfaction. It's a shadow with a clean edge, and that clean edge is Earth's roundness made visible, traced across another world. Then totality arrives, and the surprise is that the moon is still there, still present, just transformed. It's one of those moments when darkness isn't absence. It's a canvas for a different kind of light. The moon isn't generating anything. It's still sunlight on detour. Only this time the detour runs along the rim of your own atmosphere, through the warm colors that normally live at sunrise and sunset, and then outward into the night to paint a distant sphere. If you flip the viewpoint in your head, the event becomes even more unreal in the best way. From a moon during a total lunar eclipse, you'd see Earth blocking the sun. Earth would be a dark disk, and around it would be a thin ring of firelight. Every sunrise and sunset around the planet at once, a glowing halo. That halo would be the source bathing the lunar surface in red. The sky would be black, stars steady, shadows ink dark, and Earth would hang there like a huge coin rimmed with a soft ember glow. It's the same alignment you understood as geometry, but it looks like art. Even the moon's annoying dust joins the mood. Regolith is matte, full of tiny angles, built to scatter light rather than shine it back like a mirror. Under normal full moonlight from Earth's perspective, the moon can look bold and bright. under eclipse light. It looks velvety, subdued, as if the surface finally agreed to match your bedtime lighting preferences. The harsh contrast stays because there's no atmosphere to smooth it, but the overall tone is gentler, more candle than spotlight. And the whole transformation happens without noise. No flash, no crack, just a slow slide of shadow, a gradual warming of color, and a familiar face in the sky quietly changing its tone because Earth's air bent sunlight into the place where sunlight shouldn't be. It's comforting that the explanation doesn't ruin it. If anything, it makes it feel more connected. The moon wearing the color of your planet's edge, lit by the same physics that paints your sunsets, only stretched across space and time until it reaches your eyes as a calm, copper glow. That copper glow is exactly why people have never been able to leave the blood moon alone. You can explain it with refraction and scattering and the atmosphere acting like a giant lens, but the feeling it creates in a human nervous system is older than equations. A familiar light changes color. The sky does something rare. The night looks like it's holding its breath, and suddenly your brain is doing what brains do, reaching for meaning, reaching for story, reaching for a reason that feels personal. Across cultures, the eclipsed moon has been treated like a message. Sometimes a warning, sometimes a test, sometimes a sign that something invisible is moving behind the visible world. It's not hard to understand why. The moon is usually steady. It keeps its phase schedule, it keeps pulling tides with the same board commitment. When that steady object darkens and reddens, it feels like the universe has changed the rules. So people wrote rules of their own. In some stories, an animal or spirit devours the moon and then releases it. In others, the moon is injured or bleeding, hence the dramatic name that makes it sound like the sky is auditioning for a thriller. Some cultures associated lunar eclipses with shifts in leadership, with harvest fortunes, with personal fate, with the mood of the gods. If you're listening at night, in the soft calm of your room, you can almost feel the ancient logic. If the sky changes, life might change too. And then there's the human habit of taking the rare and treating it like a spotlight on whatever you're already anxious about. People don't invent new fears. They decorate old ones with celestial events. The blood moon becomes a symbol for something is coming, because something is coming is if you thought humans have at all times anyway. The eclipse just gives a costume. The calming shift happens when you let yourself enjoy the stories without letting them run your life. You can hold the legends the way you hold a folk tale, not as a literal instruction manual, but as a record of what people felt when they looked up. The moon's color changed, and they responded the only way they knew how, with narrative. They gave the sky a voice. They turned physics into personality. That's not stupidity. That's art. It's a kind of emotional science before science had its modern language. People were observing a pattern that truly matters, rare alignments, repeating cycles, and they were filing it into their culture in a way that could be remembered. The moon was eaten, the moon bled, the moon warned. Those phrases stick. They get passed down. They keep people paying attention to the sky. And attention matters, even when the explanation changes. Modern you gets to do the most satisfying version of this. You can keep the mood and upgrade the mechanism. You can look at a blood moon and feel the ancient awe, but also know the calm reason. Sunlight filtered through Earth's atmosphere. The ring of dawn and dusk. The moon lit by Earth's rim. You can be moved without being manipulated. There's also the simple fact that lunar eclipses are rare enough to feel special, but predictable enough to feel safe. That balance is comforting. The moon isn't actually breaking. The sky isn't collapsing. Gravity isn't changing its mind. The eclipse is just a temporary derangement of bodies. It has a beginning, a middle, and an end. The moon returns to its usual brightness like nothing happened, and the universe continues its steady turning. That predictability is one of the quiet miracles of science. People used to fear eclipses because they felt like an unpredictable attack on the sky. Now you can treat them like appointments, not in a boring way, more in a the cosmos is reliable way. The same geometry that makes your life feel small also makes it feel steady. Orbits repeat. Alignments come back. The moon keeps showing its face. The tides keep breathing. Even the drama has a schedule. And still, even with knowledge, the blood moon remains one of those sights that makes humans go quiet. Not because we're terrified, but because the color is so wrong compared to what we're used to seeing. Your brain tags the moon as white or silver, the way it tags grass as green. And when the moon turns red, it triggers that gentle alarm of novelty. Novelty draws attention. Attention slows you down. It pulls you into the present moment. For a little while, the night stops being background and becomes the main screen. It's also a moment that reveals how connected Earth and moon really are. In daily life, you might think of the moon as separate, its own thing up there. A lunar eclipse makes the relationship obvious. Earth casts the shadow. Earth's atmosphere paints the color. The moon becomes the canvas for Earth's edge. It's an interplanetary collaboration that just happens to look like a supernatural omen if you're watching it with no context. That collaboration echoes your earlier anchors. Earth shine as the pale glow on the crescent's dark side. Moonlight as sunlight on detour. Tides as the moon's slow massage of the ocean. Now the blood moon as Earth's sunsets projected onto the moon. The theme keeps repeating, light bouncing, bending, traveling, and turning into moods. If your mind wants to stay curious instead of restless, the moon is basically a masterclass in gentle transformations. And you can let yourself smile at how dramatic humans are about it. The phrase blood moon is honestly incredible branding. It sounds like the moon has joined a metal band. Meanwhile, the moon is just sitting there, being a rock, reflecting filtered light, minding its own orbital business. It's the same moon that can't even be bothered to have an atmosphere. The same moon whose biggest personality trait is dust that clings like it's emotionally attached to your boots. Yet we look at it glowing copper and immediately decide it's a prophecy. There's something sweet about that, too. Humans want to feel included. We want a sky to notice us. The blood moon feels like the sky, turning its attention toward Earth for a moment. And in a sense, it is, because Earth's atmosphere is literally participating. The planet is, in that moment, a lens, and the moon is showing you the result. It's not about you, but it is about your home. So you can keep the stories as ambience, and let the science be the safety net. Let the legends give the event texture, and let the physics give it peace. The moon turns red because light bends and scatters. The eclipse happens because orbits line up. The event ends because the moon keeps moving. Nothing is stuck. Nothing is broken. The sky is just doing geometry in slow motion. And that calm is what you carry forward into the next part of the night. Because once you've seen the moon as a face written in lava, as a clock for months, as a tide maker, as an archivist of craters and footprints, and as a canvas for Earth's sunsets, it becomes hard to look at it as mere decoration. It becomes a companion in scale, vast, mysterious, but also understandable in a way that doesn't spoil the wonder. The moon keeps hanging there with that steady, unbothered patience, even after you've watched it borrow sunlight, where myths pull oceans and blush copper in Earth's shadow. It's almost unfair how calm it stays while humans do what humans do, spin stories, argue over omens, lose sleep, then blame the sky like the sky owes us an apology. So you imagine the next time the moon decides to perform that rare color shift again, not as a headline you chase, but as a quiet appointment with the universe. You picture yourself noticing the night earlier than usual, catching the moon low and pale, watching it climb while the world keeps doing its noisy little routines. Somewhere a streetlight hums. Somewhere a motorbike fades into the distance. Somewhere a dog chooses the worst possible time to announce its opinions. And above all of it, the moon continues, indifferent to the soundtrack. In your mind, you're already outside, or at a window, or on a balcony with the air just cool enough to feel like a soft reset. You don't need a telescope to be moved by this. The moon is generous that way. It's the one celestial object that insists on being visible, even to a tired person with half-closed eyes. It's built to be a companion. It doesn't hide its face, it doesn't twinkle away like a shy star. It just shows up like it promised it would. You remember the first thing you learned tonight, before the science piled up and became a kind of gentle weight in your chest? Moonlight is not a light of its own. It's the sun's voice softened by distance and rock, the bright day translated into a quieter language. That makes the blood moon feel even stranger, because it's the moon speaking in a different accent. Sunlight strained through Earth's atmosphere, warmed by every sunrise and sunset at once, then delivered to the lunar surface as a dim ember glow. That ember glow arrives slowly. That's on the best parts. It's not a jump scare. The moon starts as itself, familiar, silvery in your night vision, the Maria and highlands arranged into a face your brain refuses to stop reading. Then the shadow begins. At first, it's barely a dimming, like the room lights lowered by a careful hand. The penumbra passes, and you might doubt you're seeing anything at all, until you notice the moon looks tired. Not smaller, not broken, just subdued. Then the umbra reaches it, and the curve of Earth's shadow creeps across that familiar face, and the night suddenly feels more three-dimensional. You can see Earth in the shadow's shape. You can feel the geometry without doing any math. A round planet casts a round shadow, and the moon accepts it like it accepts everything, quietly, with no argument. As that dark bite advances, your thoughts drift back to the moon's surface because it's hard not to. Those basalt seas that aren't seas formed when lava flooded ancient impact basins and then froze into smooth plains. Those bright highlands, older and more heavily cratered, a pale crust that's been keeping its shape since the moon's earliest cooling. Impacts turning rock briefly liquid under pressure, carving craters with rims and terraces and central peaks, then leaving them there like permanent punctuation marks. And the dust, sharp, clingy, glitter with a grudge, waiting in every hollow where the light can't reach. A place with no wind and no rain, where a footprint can stay crisp long enough to outlast your entire species' mood swings. It's quietly hilarious that the same world that looks so clean from here is coated in abrasive powder that would happily sandpaper a spacesuit for entertainment. The moon doesn't need to be dramatic. It can be quietly inconvenient and still magnificent. That's why the blood moon hits so hard. A calm transformation laid over an uncompromising landscape. The moon never learned to blur, so the edge of shadow stays clean. The sky behind it stays black. The stars stay steady. The only thing that changes is the moon's light, and that change feels enormous because everything else refuses to move. Then the moment people love to name arrives. Totality. The moon is fully inside Earth's umbra, and instead of vanishing, it glows like a coal. Dim, warm, coppery, and that is Earth's atmosphere speaking. Your planet is acting like a lens, bending sunlight through layers of air, peeling away the blues, leaving reds and oranges, then spilling that warmed light into the shadow and onto the moon. It feels personal in the simplest way. The moon is cold and airless. Earth is warm and wet and loud. During a blood moon, Earth reaches out without touching and paints the moon with the color of its own horizons. You're looking at a distant rock lit by the tint of your own atmosphere, and the distance doesn't make it less intimate. It makes it more. You can almost hold that in your hands, because your hands are part of the system too. They're on Earth. They're inside Earth's air. When you breathe in, you're breathing the lens. The air you ignore all day becomes part of the night's strangest color, and your mind loops through the other connections without forcing them. The moon pulls tides, lifting and lowering shorelines while you're busy being human. The moon is tidally locked, holding eye contact because gravity trained it into steadiness. It nods and rocks with libration, letting you peek a little past the edges, like a secret shared slowly. It keeps the scars of the early solar system visible because it has no weather to erase them. It keeps the human marks too, tracks scuffs, disturbed dust, because it doesn't do forgiveness by erosion. It simply keeps. Even the myths feel softer when the moon is red. You can understand why people once thought something was eating it. The familiar face dims. The color turns uncanny. Your nervous system wants to assign a story. But with the science held gently in your mind, the story becomes calmer. Nothing is eating the moon. Nothing is bleeding. The moon is passing through a shadow, lit by filtered sunlight. The drama is in the name, not in the mechanism. And still, the mechanism is magnificent. Think about what has to happen for you to see that copper disk. Earth has to be in the right place. The moon has to be in the right place. The nodes have to line up with the sun. The moon has to cross into the umbra instead of slipping above or below. Your local sky has to cooperate. Your attention has to be awake enough to notice. So many conditions, and yet it happens often enough that it feels like an invitation rather than a lottery. That invitation is the opposite of urgency. The moon isn't asking you to chase it. It's asking you to witness, to be present in your own life for a while, under a sky doing something quietly rare. And when the eclipse releases, the red fades. The moon brightens from ember to dull gray, from dull gray to familiar silver. The shadow slides off like a slow curtain being drawn back. The face returns. The streetlights keep buzzing. The night keeps being night. The universe doesn't announce the ending. It simply moves on. That's the conclusion you get to keep. The moon can change without being broken. The sky can do something strange without it being a threat. Darkness can arrive and leave without taking anything from you. Even a blood moon, with all its dramatic branding, is a reminder that the most powerful events in nature can be quiet, predictable, and temporary. And that kind of reminder is exactly what your body wants at bedtime. You spent the day under bright light, sharp tasks, fast decisions. The moon offers you slow motion. It offers you repeated cycles that don't demand perfection. It offers you the idea that time can be measured in soft shifts, not only in alarms and deadlines. You keep the image of the moon's copper face for a moment longer. Warm light on cold rock, Earth's sunsets wrapped around the planet and poured across space. The night feels larger, but it also feels safer because it's governed by steady motions and gentle physics. Your thoughts don't need to race to keep up with it. The moon stays where it is, and the room stays where it is, and your breathing becomes the smallest, most reliable rhythm in the whole scene. In and out, like a tide you can't see, like a pull you don't have to fight. The thoughts that kept poking at you earlier lose their edges. They soften into something you can watch without grabbing. If a worry floats up, it can drift past like a thin cloud crossing the moon's face, bright at the edge, then gone, leaving the light unchanged. Your eyelids feel heavier in a way that doesn't demand anything. Your shoulders settle. The world doesn't need your attention for a while. It can keep turning without you watching it. You can imagine the moon high above, silent and calm, its surface covered in old craters and old dust, holding old footprints without judgment. You can imagine Earth below it, wrapped in air and warmth, wrapped in the soft chaos of weather and light. That air, the same air that bends sunlight into copper for a blood moon, rests all around you, touching your skin, filling your lungs, making the night gentle enough for sleep. The image in your mind fades from sharp detail into a soft glow, like moonlight through a curtain. The copper ember becomes a warm memory. The silver disk becomes a quiet idea. The sky becomes a dark blanket with one calm light stitched into it. Far away, steady, patient, completely unbothered. And your breathing keeps its slow rhythm, carrying you downward into that private place where thoughts stop being sentences and become simple shapes, and then even the shapes dissolve, and the night holds you the way gravity holds the moon, firmly, gently, without effort, without noise, until sleep arrives like a soft closing of the door.